Hello viewers, Wagdaru now taking you through the story for O-level math contest practice. And this video is a compilation of Introduction to Geometry Part 1. So like I told you in the previous videos, we chose to make these compilations basically for O-level students who hope to participate in the national math contest, but also for those who are joining A-level but did not do math contest in O-level, yet they wish to do math contest in A-level. So for that, if you are such student, I encourage you to watch this video so that you get on the same level with those who did math contest in O level. Otherwise, we hope to begin trainings for now A level math contest practice once we are done with releasing these compilations. Before I begin, allow me to display some of the books which may be of good help based on your syllabus. Not on math contest, but for the syllabus. There is math for Senior 1 and Senior 2, and also the item bank. The item bank is complete, Senior 1 to Senior 4, but the notes are still Senior 1 to Senior 2. We are working so that we can make it complete. Then physics, for it, it's already complete, Senior 1 to Senior 4 notes, and also the item bank is complete, Senior 1 to Senior 4. So for the copies, you contact the author on this contact. That is O level. Then A level, we have these books also. Math 1, Math 2, and the item bank for Math 1. Physics 1, Physics 2, and the item bank for Physics 1. What is pending in A level is the item bank for Math 2 and also for Physics 1, and we are working on those. So those two remarks, I can leave you to enjoy the video of Geometry Part 1. Hello viewers, Warogadaru now taking you through the story of O-level math contest practice. And this video, I'm going to go through the topic of angles and polygons. So this topic is under geometry and will be suitable for students in both Senior 1 and Senior 2 with a passion of one day participating in the National Math Contest and thereafter Math Olympiads. So we are now in week 2 of the holiday. So in week 1, remember we covered Introduction to Algebra. And this week we shall cover Introduction to Geometry. And this will be the agenda of this week. Of the 6 days, remember we learned from Monday to Saturday. So today, in this day 1, we shall go through the topic of angles and polygons. And at the end, I'll leave you with an assignment. Now, in the previous week, the assignments were got from National Math Contest past papers. And this week, the assignments will be got from the Intermediate Math Olympiad and Kangaroo papers. So angle properties, they're similar to the ones you covered in primary, but we shall go through them because they are necessary in this math contest. So there are some terminologies which you need to look at before we go to the angle properties, and that is, one should remember that any two angles with sizes which add up to 90, they are called complementary angles. If they add up to 180, then they are called supplementary angles. Then if two angles have the same vertex and share a common arm, they are called adjacent angles. So in this figure, you're going to realize that these two angles, X and Y, have a common vertex, which is A, and also share a common arm, which is this. Therefore, they qualify to be called adjacent angles. Then also for intersecting lines, angles which are directly opposite each other are known as vertically opposite angles. For example, if you have two intersecting lines, then this angle and this angle will be called vertically opposite angles. Similarly, this angle and this angle are also known as vertically opposite angles. So basically, those are the brief terms: complementary angles, supplementary angles, adjacent angles, and vertically opposite angles. So with those ones in mind, you can now go through the properties of angles, which are beneficial when solving some problems involving angles. The first property is angles centered at a point. So here you should remember that the sum of the sizes of the angles at a point will always add up to 360. So let's get an example. Suppose we have a point here. So the sum of these angles, 1, 2, 3, when you add up all those angles, they must add up to 360 degrees. Now I want you to realize something. Here, I've not just put A, B, and C. I've put A with a degree sign, B with a degree sign, C with a degree sign. And that is what is advisable in these math contests and math Olympiads, such that here you don't have to show that this is 360 degrees. So when you put here the degree, it means that now A, B, C are just numbers. But if by mistake you don't put them there, it means that each time there is an angle, you should write a degree sign in your calculations throughout, which is a little hectic. So I advise you to always, if there is an unknown, put a degree sign, provided you are in a math contest or math Olympiad. That was property number 1. Property number 2, adjacent angles on a straight line. So this one says that the sum of the sizes of angles on a line will always add up to 180 degrees. In other words, they will be supplementary. For example, let's illustrate that. We have a straight line, then we have these two angles A and B. That means that when I add them up, I must get 180 degrees because they lie on a straight line. That is property number 2. Then property number 3 is about adjacent angles in a right angle. So the sum of the sizes of the angles in a right angle will always be 90 degrees. In other words, these angles will be complementary. For example, if I have that right angle, it means that these angles, the two angles A and B, must add up to 90 degrees. Then property number 4 is about vertically opposite angles. The good thing now we know what vertically opposite angles are, and it says that vertically opposite angles are equal in size. For example, if I have these two angles A and B, which are vertically opposite, it implies that A is equal to B. That was property number 4. Now we shall go to property number 5. Property number 5 is about corresponding angles. So when two parallel lines are cut by a third line, then the angles in corresponding positions are equal in size. So let's see what that means. Those are two parallel lines cut by a third line, then the angles in corresponding positions will always be equal in size. That means that A is equal to B. That was property number 5. Then property number 6 is about alternate angles. So say that when two parallel lines are cut by a third line, then angles in alternate positions are equal in size. So let's try to illustrate that. So you have two parallel lines, then a third line, and angles in alternate positions are equal, meaning that A will be equal to B. That is property number 6. What about property number 7? Property number 7 is about co-interior angles, also known as allied angles. It says that when two parallel lines are cut by a third line, then co-interior angles are supplementary. I think you remember what the word supplementary means. It means that they add up to 180 degrees. So the co-interior angles will be these ones, A and B. Meaning that when I add A plus B, I must get 180 degrees. So those are the 7 properties involving angles. And with that, we shall go through this example. So I'm going to give you just one example because I assume in primary level, you covered a number of examples and exercises. So it says that find the value of x and y in the figure below. So these arrows mean that these two lines are parallel. And now this will be the third line. That means this angle and this angle are corresponding. Then this angle and this angle are co-interior. So let's begin with the ones which are corresponding. They'll be equal, so it's a linear equation which can be solved, collect like terms, and make x the subject. So what I've done, brought the 100 this side and brought this x this side. Then shall go to co-interior angles. This plus this is equal to 180. The good thing I know the value of x, so come and substitute for x and get the value of y. And basically that is what they wanted. I think you realize that because here there is a degree sign, my values do not have a degree. That's what should always be keen with. And becomes easier because if you don't put this degree sign, it means I need to see a degree, a degree, a degree like that. So now shall go to polygons. And a polygon is simply any closed shape which has 3 or more sides. And these polygons can be regular or irregular. So regular means all sides are equal and all interior angles are equal. Otherwise, it becomes irregular. And the polygon with 3 sides is known as a triangle. And this, for example, this shape is for a triangle because there are 3 sides, 1, 2, 3. And these triangles have something in common. There are many types of triangles, but all of them have 2 properties in common. The first one is that the sum of the interior angles of a triangle is 180 degrees. Therefore, that means that if I add all these interior angles, I must get 180 degrees. The second property, which is common to all, is that the size of the exterior angles of a triangle is equal to the sum of the interior opposite angles. So if I come here and I add an exterior angle, it must be equal to the sum of the opposite interior angles. So these 2 properties are common to all types of triangles. Now let's look at the types of triangles. So there are basically 4 types which you are familiar with. So one is an equilateral triangle. This one, all angles are equal and they are each 60 degrees, as you can see here. Then 2, all sides are of the same length. And 3, it has 3 lines of symmetry. For an isosceles triangle, 2 angles are equal. I think you can see here, this and this, they are equal. Then the second property is that 2 sides are the same length. So this side and this side are the same length. Then it has only one line of symmetry, which is this. And what you realize that it bisects this angle into two equal parts, and also here it meets at 90 degrees. Then the third one is called right angle triangle. Here one of the angles is 90 degrees. So this will be 90 and these ones can be any other angle, provided they fulfill the first property of all triangles, that when you add all the three, you get 180 degrees. Then two, that all sides may be of different lengths, just as you see here, this and this are of different lengths. Then here they said all angles may be different. Then it may have 0 or 1 line of symmetry. It can have 1 line of symmetry if this length is equal to this length, and in that case it would have become an isosceles triangle. Then the fourth type is called a scalene triangle. So here all angles are different. This, and this, they are different. And two, all sides are different lengths. This, and this are different, and no line of symmetry. There has been triangles or three-sided polygon. What about four-sided polygon? Four-sided polygon are known as quadrilaterals. For example, if I have this shape, it has four sides, meaning it's a quadrilateral. And what we need to know about quadrilateral is that the sum of the interior angles is always 360 degrees. So when I get these angles and I add all of them, I must get 360 degrees. And these are the types of quadrilaterals. There are actually 6. So one is a square. For a square, all angles are right angles. The mean interior angles, I think you can see here, 90, 90, 90, 90. That's what they mean. Then two, all sides are the same length. This side is the same as this, same as this, same as that. Then two pairs of parallel lines. So this line is parallel to this, that's one pair. This is parallel to this, that's the second pair. Then four lines of symmetry. It has this line, this line, this line, and this line. Then for a rectangle, all angles are right angles. So here, this is 90, 90, 90, 90. Then opposite sides are of the same length. This length is equal to this length, and also this length is equal to this length. Then opposite sides are parallel. This line is parallel to this, and this line is parallel to this. Then two lines of symmetry. So it has this line of symmetry and also this line of symmetry. Then for next will be a rhombus. A rhombus, for it, opposite angles are equal. If you look at this angle and this angle, they should be equal. And also this angle and this angle, they should be equal. Then two, all sides are of the same length. All sides are the same length. Then opposite sides are parallel. This side is parallel to this side is parallel to this. And two lines of symmetry. So when the two lines of symmetry is this and this. Then that was the rhombus. Then parallelogram, someone similar to a rhombus, but for it has some differences. One, opposite angles are equal, just as the rhombus was. These angles are equal. Then opposite sides are of the same length. So this is where the difference comes in. Here all sides were same length, but here it is only opposite sides which is same length. So this side is equal to this length, and this length is equal to this length. Then two pairs of parallel lines. So this is one pair, this is another pair. Then no line of symmetry. Then trapezium, all angles may be different. There's a trapezium, then all sides may be different. Opposite sides are parallel. So one you should remember is that What makes it a trapezium? These two must be parallel and may have no lines of symmetry. It can have if it is an isosceles trapezium. Then lastly is a kite. A kite, one pair of equal angles. So there's a pair of equal angles. These equal angles are these ones. There is this and this, which are equal. Then two adjacent angles are of the same, adjacent sides are the same length. So this same length as this, and also this same length as that. Then no pair of parallel lines. There are no parallel lines. Then one line of symmetry. It only has this line of symmetry. So those were the four-sided polygon. What about other polygons? For other polygons, there's something we need to write. Now we need to write the formula, which is used to get the interior angle sum. Remember, for triangle, we said interior angle sum is 180. For quadrilaterals, the interior angle sum was 360. But what about other polygons? So for you to easily remember the interior angle sum, you need to remember the formula used to get the interior angle sum and also the exterior. Now, how do we get the interior? One should remember that the sum of the exterior angles of any polygon is 360. So any polygon, whether it's 5-sided, 4-sided, 3-sided, 12-sided, 20-sided, it has to be 360 degrees. So this is what I mean by exterior angles. This angle is an exterior angle. All those are exterior angles. And when you add all of them, you must get 360 degrees. Now, since the exterior angle of a regular polygon are equal, these are equal, we may deduce that each exterior angle of a regular polygon with n sides is equal to 360 divided by the number of sides, which is also true. Then the interior angle sum of n-sided polygon will be given by this formula, 180 in brackets n minus 2. You should always remember that. For example, if you use it for a triangle, put here 3. It becomes 3 minus 2, which is 1. 1 times 180 to give you 180, which is so earlier. If it is a 4-sided polygon, put here 4. 4 minus 2 is 2. 2 times 180 is 360, which is so earlier, meaning that it holds for all other polygons. So that implies that each interior angle for a regular n-sided polygon is this interior angle sum divided by the number of sides. So the first two, the names are a little okay, quadrilateral and triangle, but the others, the names look a little weird, but they're good enough you cover them in your primary. So let's look at some of the common shapes. The first one is a pentagon, which is 5-sided. So the interior angle sum, remember I got it from this formula, where there is n, put 5. 5 minus 2 is 3. 3 times 180 is 540. So that is the interior angle sum of a pentagon. Meaning if it's a regular pentagon, each interior angle is 540 divided by 5 to give you 108 degrees. Therefore, if you have to draw a regular pentagon, you should make sure that each interior angle is 108 degrees. So to draw it well, it's better you first come up with a circle, then you can put in the sides to make sure that all sides will be equal. Then you put in the interior, each interior angle should be 108. And that is the shape of a regular pentagon. It must be regular. If it is irregular, it can even appear like this. For example, here you see these are the same, but the funny thing is that this one is different from the rest. That means that it is no longer a regular pentagon. It is an irregular pentagon. But what you should remember that interior angle sum is the same provided it's a 5-sided. So when I add all these angles, I will get 540. So same correct like terms, make x the subject, and that's what they want. Now we shall go to the 6-sided. 6-sided is called a hexagon. So go through the same procedure, the interior angle sum, where there's input 6, then 6 minus 2 is 4, 4 times 180 is 720. That is the interior angle sum of a hexagon, meaning that each interior angle for a regular hexagon will be 720 divided by 6 to give you 120 degrees. That means that the regular hexagon can be like this. Like I told you, it's better if you first draw a circle, then you can put in your hexagon. Then each angle will be 120 degrees. So that's how a regular hexagon looks like. Irregular, it can be in this form, and I wanted you to find the value of x, so you should remember that the interior angle sum is always the same. So you come and add all the values and equate them to 720, collect like terms and make x the subject. And that's what they wanted. Then for a 7-sided, you can call it a 7-gon or heptagon. So still, where there is n, come and put there 7. 7 minus 2 is 5. 5 times 180 is 900, which is the interior angle sum. Meaning that for a regular heptagon, each interior angle will be this. Now this is the decimal, meaning that because if you use a calculator, there are very many decimals here only rounded off. That is why I put this approximate sign. That means that the shape will only be approximate. So I'll come and draw my approximate heptagon. Now the angles, I will not put the actual angle because remember I rounded off. I rounded them off, and if I put this exact angle here and I add all the angles, I'll end up not getting 900 because of this rounding off. Actually, if we say 128.57 times 7, you realize you get 899.99. That is why I chose not to put an exact angle here, because if I put this exact angle here, someone will get a calculator and add up all these values and realize that the angle, the interior angle sum is not 900, which will have violated this rule which is stated. So allow me not to put and just call it approximate. Then for an irregular heptagon like that, we should remember that interior angle sum is the same, so add all and equal to 900, collect like terms, and make x the subject. Then octagon or 8-gon, which is 8-sided, where there is n, put there 8. 8 minus 2 is 6. 6 times 180 is 1080, meaning that for a regular octagon, each interior angle will be 135 degrees. Therefore, I can now draw my regular octagon. So that becomes the octagon. Each side, each interior angle is 135 degrees. For an irregular one, it can be like that, but we should remember that the interior angle sum must be must be 1080. So add all the angles and equate them to 1080. Then collect like terms. Simplify and make x the subject. And that's what they wanted. So nonagon, it means it is 9-sided and can be of this shape. Interior angle sum is 140. Each interior angle will be 140. Then for 10-sided is called 10gon or decagon, which is interior angle sum is 144. Then for 12-sided is called 12gon, and each interior angle is 150. And lastly, 20-sided is called icosagon or 20gon, and each interior angle is 162. So the more the number of sides increase, the more it approximates to a circle. I think realize here there was some space here, but here it is almost negligible. So it is very close to a circle. So that was the lesson for today. What I want to remember, I told you the assignments will come from I am okay. So I wanted you to first know what I am okay is. So this is an intermediate math Olympiad based in UK, and it's provided by the United Kingdom Mathematics Trust, UKMT. If you Google it, you'll find it there. So this Math Olympiad is the follow-on round of the intermediate math challenge. So they first have math challenge. For us, we have math contests, but for them they have math challenge, and from there they go to intermediate math Olympiad, then math Olympiad. For us, we have national math contest, then it's from there that we select those to go for IAMO, PAMO, and IMO, as I already showed you in the previous videos. So these math Olympiads are for children in the age bracket of 13 to 16, and I believe even you are among this age bracket. Now they categorize their papers into 3 based on the age. So the first paper is this, Kylie, and it is for students in the age 13 to 14. Then Hamilton, 14 to 15, and Macrarine for 15 to 16. That means that in your assignment, if you see Kylie, it means that it was got from a paper which for students in the age bracket 13 to 14. If you see the word Hamilton, it means it was got from a paper for students in the age bracket 14 to 15. And if you see Macrarine, it means it was got from a paper of students within the age 15 to 16. What I should reemphasize is that these math Olympiads, they don't allow you to use a protractor. Math Olympiads, they don't allow you to use a protractor. So that brings us to the end of this video. Thank you for watching, and Be reminded the next video will be on Pythagoras theorem. So if you have not yet subscribed, please click on the subscribe button below this video such that you can receive updates when the next video has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that you can all benefit as a family. Hello viewers, Wardaruna taking you through this story for O-level math contest practice. And this video I'm going to go through the part of Pythagoras theorem. This part is under geometry and is suitable for students in both senior 1 and senior 2 with a passion of one day participating in the national math contest and thereafter math Olympiads. So this is our agenda for week 2. Remember, week 1 we covered algebra, introduction to algebra, and now this week we shall cover introduction to geometry. So day 1 we already covered that, and now we are going to cover Pythagoras theory, and I'll leave you with an I am okay assignment 2. So a good thing, Pythagoras theory, this theorem was covered in your primary and you also cover it in your O-level syllabus. But because it is available in the math contest, that's why we are repeating it. So this theorem is specifically for right-angled triangles. So a right-angled triangle is a triangle which has a right angle as one of its angles. So here, if you see this, it means that it's a right-angled triangle. The side opposite to the right angle is called hypotenuse. So this is the right angle, the side opposite is this. And that's what you call the hypotenuse. And is the longest side of the triangle. So it is the longest. Remember, the triangle has sides A, B, and C. So the hypotenuse is the longest. The other two sides are called the legs of the triangle. So this side A and side B are what we call the legs of the triangle. So Pythagoras theorem therefore states that in any right angled triangle with hypotenuse C and legs A and B, the relationship among the three is given by the square of the hypotenuse is equal to the sum of the squares of the legs. That's what you should always remember under Pythagoras theorem. Then we have what we call Pythagorean triples. So these triples help you to easily identify whether a triangle given is right angled, because in Math Olympiad they may not put this right angle sign as you see it here. So it is due to look at the sides given and be able to identify that this is a right angle. So these ratios there are ratios of right angled triangles. For example, if I have one side as 3 and the other side as 4 and the other side as 5, it means it is a right angled triangle. Now, why am I putting 5 here? It is because we said the hypotenuse is the longest side of the triangle. So these ones can be interchanged. For example, I can still say that this side is 4, this side is 3, but this must remain 5. So the longest must be on the hypotenuse. So each time you see these sides, just know that it's a right angled triangle. Similarly, for this, if you see 5 here and 12 here and the longest side here, it means it is right angled. Similarly, this can be interchanged. I can put 12 here and 5 here, but the 13 cannot change because always the longest side must be the hypotenuse. Similarly, if I have 25 here, then I have 7 and 24, it is right angled. If I have here 24 and here it is 7, it is still right angled. Also, if I have here 17, 8 and 5, 15, sorry, it is right angled. Or if I interchange and I put here 15 and put here 8, it is still right angled. Now, why are we giving ratios? Ratios means there are multiples of these ones are also right angled. For example, this one, if I multiply throughout by 2, I'll come up with 6, 8, and 10. Meaning that if I have here 10, and here I have 6, and I have here 8, it is a right angled triangle. I can multiply by any. For example, if I multiply by 10 here, it will be 30, 40, 50. So if I have 50 here, and I have 30 here, and I have 40 here, it is still right angled. That's what these ratios mean. Multiples of these ratios are all right angled triangles. So in given shapes, look at the sides given and analyze whether they are right angled or not. Then we also have particular angles. Sometimes they can give you angles and sides. Then it is easy to look at them and identify that this should be right angled. So for example, if they give an angle 60 and realize that the hypotenuse is twice this side, which they look at the sides which enclose the angles. So if the hypotenuse is twice this leg, then it should be right angled at this point. Similarly, if it is 45 and you realize that the legs have the same length, this leg and this leg, they have the same length, then it should be right angled triangle. Then if it is 30 degrees, actually is this the same triangle as this, because if this is 60, here it will be 30. So same procedure, only that now here, the side which is half the hypotenuse is the opposite of that angle. So with that knowledge, we shall go through these examples. Question 1 says, an equilateral triangle has sides of length 12 centimeters. Find the length of one of its altitudes. So equilateral triangle, all sides are equal. So we shall come and say, let h be the length of each altitude. Because all the altitudes of an equilateral triangle are the same length. So I'll come and sketch, then I'll get that as the height of the altitude, and this will be the sides. Now this one has been divided into 2, so this line is a line of symmetry. It divides this length into 2, that's why you see here 6 and 6. And when you do that, this becomes a right angled triangle. BCD becomes a right angled triangle, and therefore I can use Pythagoras theorem. When I use it, I'll come up with hypotenuse squared is equal to the sum of the legs. So come and substitute and simplify. This squared is that, this squared is that. Then collect like terms, take this 36 this side, give you that. Then subtract the 2, get h squared as 108, and put a square root on both sides to get the value of h as that, to 4 decimal places, and that's what they wanted. Then question 2, a square has diagonals of length 10 centimeters. Find the length of its sides. So still we shall come and say let x be the length of each side. So we shall come and sketch a square with sides x and diagonal 10. So this is a right angled triangle. So I can use Pythagoras theorem by saying the square of the hypotenuse is equal to the sum of the squares of the legs. So come and substitute, simplify, this becomes 2x squared, then divide both sides by 2, then put square root and get the value of x, and that will be the length of each side. Then question 3, a rectangle has sides of length 8 centimeters and 3 centimeters. Find the length of its diagonals. So let x be the length of each diagonal. Therefore, we shall come and draw a rectangle, put the sides and the diagonal. So this diagonal is the hypotenuse. Therefore, I'll come and substitute in Pythagoras theorem. When I substitute, I'll come up with x squared equal to 8 squared plus 3 squared. Simplify, add these two to get, then put a square root and get the value they want. Then question 4 says the longer side of a rectangle is 3 times the length of the shorter side. If the length of the diagonal is 10 centimeters, find the dimensions of the rectangle. So let x be the length of the shorter side, meaning that the shorter side will be x and the longer side will be 3x. And the diagonal they give us as 10. So still I'll use Pythagoras theorem. So substitute hypotenuse, then this longer side and shorter side. Simplify, then add the correct like terms to get 10x squared, divide both sides by 10, and put a square root. And that will be the answer they wanted. Question 5 says, a rhombus has sides of length 6 centimeters. One of its diagonals is 10 centimeters long. Find the length of the other diagonal. So we shall need to sketch a rhombus. Then put the diagonals. Then one length they said 10 centimeters long, so it divides into 2, 5, 5. The other one is 2x, meaning one is x, the other one is also x. Then they said find the length of the other diagonal. So what we do, we can extract out one right angled triangle and use Pythagoras theorem. So we have chosen BOC, which is this. 6 is the hypotenuse, 5 and x are the legs. Simplify, collect like terms, we'll come up with that, then put a square root, and that will be the, so that is the value of x, but the length is 2x. So you'll come and conclude that the length of the other diagonal is 2 times the x, which is that, and that's what they wanted. So now I shall go to question 6. Question 6 says, to get to school from her house, Ella walks down Bernard Street, then turns 90 degrees and walks down Thompson Road until she reaches her school gate. She walks twice as far along Bernard Street as she does along Thompson Road. If Ella's house is 12.5 kilometers in a straight line from her school gate, how far does Ella walk along Bernard Street? So we shall come and say that let x be the distance walked along Thompson Road. Then we shall come and draw a triangle, right angle triangle, because they said first it was Bernard Street, which is twice this distance. Then she turns 90 degrees, so we go 90 degrees, and there the distance will be x. Then from a straight line from the starting home to the school gate is 2.5 kilometers. So this is a right angle triangle, and you can use Pythagoras theorem. So come and substitute, simplify, collect like terms, divide both sides by 5, and get square root. So that will be the value of x, but they say distance along Bernard Street, which is 2x. So you conclude and say the distance walked along Bernard Street is 2x, which is 2 times that, to give you that as the answer. And that's what they wanted. So I think in the previous video we talked about these intermediate math Olympiads and there are 3 papers. If you see Kylie, it means the question was got from the paper of students in the age bracket this. If you see the word Hamilton, it was got from a paper of students with age bracket this. And if you see McLaurin, it means it was got from a paper of students with age bracket this. But protractors are not allowed. So that brings us to the end of this video. Thank you for watching, and be reminded this video will be on area and perimeter of different figures. So if you have not yet subscribed, please click on the subscribe button below this video. And also, if you know any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so I can all benefit as a family. Hello viewers, we're taking you through the story for O-level mathematics contest practice. And this video I'm going to go through the part of area and perimeter. So this part is under geometry and is suitable for students in both senior 1 and senior 2 with a passion of one day participating in the national mathematics contest and also math Olympiads. So this is our agenda for this week, and we are now in day 3. So day 1 we covered angles and polygons and left you with assignment. Day 2 we covered Pythagoras theory and I left you with assignment. Now we're on day 3 where we're going to cover area and perimeter, and I'll leave a third assignment. Let me hope you are faring well with the assignments. So area, all around us we see surfaces like walls, ceilings, paths, and ovals. All these surfaces have boundaries that help to define the surface, and an area is the amount of surface within specified boundaries. So the boundary is the perimeter, but the amount of surface within this is what we call area, and hence the topic area and perimeter. So the area of the surface of a closed figure is measured in terms of number of square units it encloses. On the other hand, the perimeter of a figure is the measurement of the distance around its boundaries. So this distance around its boundaries is perimeter, but the square units inside that, but enclosed by that boundary, is what we call area. So for a polygon, the perimeter is obtained by adding the lengths of all sides. We shall look at some of the regular shapes which we commonly know. One is a square of side L. In this case, the perimeter will be 4L because it will be L plus L plus L plus L. But the area will be L squared because it is length L times L. Next is a rectangle. For a rectangle, it has dimensions of L and W. So the perimeter will be length plus width plus length plus width, which becomes 2L plus 2W. And when you factorize out 2, you come up with this expression. Then for area, it is length times width. Then for triangles, triangles are of different shapes, but what you need is to get the height and the base. When you have these two, you can get the area of that triangle. So in this triangle, this is a right angle triangle, it has a height and a base. For this one, it means you have to measure this height and the whole of this base. For this one, still you have to measure this height and the whole of this base. So when you have the height and the base, the area will become a half times base times height. Then when it comes to a parallelogram is of that shape. It has two pairs of parallel sides. This side is parallel to this, and this is parallel to this. What we need is the height between these two parallel sides, and that will be the height. And then the base is from here up to here. So when we get that, we shall come up with the area being equal to base times height. Then for a trapezia or trapezium, they have two shapes. There's one which is like that. So the trapezium, like we said, it has one pair of parallel sides. If you look at this and this, it is parallel. Also, when you look at this and this, it is parallel. Then the other sides are not parallel. That makes it a trapezium. So in this case, the shorter side will be called A and the longer side will be called B. Shorter side A, longer side B. And this distance between the two parallel sides is what we call H. So when you do that, we shall come up with a formula that area is the average of the length of the two parallel sides, average of these two, multiplied by the distance between the two parallel sides. So average is that, this plus this over 2 times this, which is H. If I rearrange, I'll come up with this, and that will be the formula for area of a trapezium. Then we shall go to a circle. A circle can be got the area over diameter. Now here the perimeter of a circle, we call it circumference. Then the area, so circumference and area can be got either in terms of diameter or in terms of radius. Let's start with circumference. Circumference in terms of radius, it will be 2 pi r, where r is a constant. It's also there on your calculator if you got your calculators, but this value is 3.14 or 22/7. So in terms of diameter, it is just pi d. That is circumference. What about area? In terms of radius, it is pi r squared. In terms of diameter, it is a quarter pi d squared. So any of the two is okay. That was circle. Then a sector. A sector is part of a circle. For example, this is the whole circle, but they want the area of just part of it. So for you to get the area of a sector, you need to get this angle subtended at the center of the circle. Then also the radius of the circle. So in that case, we can get the area and then this length of this curved part. Remember here, circumference was the length of the whole of this curved part. But now what about just part of this sector? what will be the length? We call it arc length, and it's given by this angle in degrees divided by 360 multiplied by the total circumference. It's like a fraction of the whole circle. In terms of diameter, still the same thing. 360 over 3 theta over 360 times the circumference. And the same will apply to area. Still theta over 360 times the area. Theta over 360 times the area. Then for quadrants, quadrant is just simply a quarter of a circle. So this angle will be 90. So the formula will be similar to the one for sector, but this time it will be 360, the angle will be 90. Now we are seeing here the word a quarter because 90 over 360, when you reduce, you get a quarter. That is why you use a quarter. So multiplies area. Then for a semicircle, the angle is 180. So 180 over 360 is a half. So here we shall simply put a half for arc length and also a half for area. So with that, I'll leave you with an assignment. Like I told you, Kylie is for edge bracket this, Hamilton this edge bracket, and this is for this edge bracket. But for you, will attempt all. But remember, protractors are not allowed. That brings us to the end of this video. Thank you for watching, and be reminded that this video will be on circle properties. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. So if you know any student who is not yet on this platform, please share the link of this video on number social media platforms like Facebook and WhatsApp so you can all benefit as a family. Hello viewers, so I'm taking you through the story for O-level math contest practice. And this video, I'm going to go through the part of circle properties. So this part is under geometry and is suitable for students in senior 1 and senior 2 with passion of participating one day in the national math contest and also math Olympiad. So this is our agenda and we are now in day 4. So day 1 was already covered and I hope you fared well in the assignment 1. Day 2 is this, we covered Pythagoras theory. I hope you fared well in assignment 2. And day 3 we covered area and perimeter and I hope you fared well. So now we are on day 4, which is circle properties, and I'll leave assignment 4. Then day 5, that's when we shall go through solutions for assignment 1 and 2. And day 6 is when we shall go through solutions for assignment 3 and 4. Now in day 1, we covered angles and polygons, where I discovered angle properties like corresponding angles, alternate angles, vertical opposite angles, and so on. But those angle properties involved only lines. But what if there is a circle involved? There we go to properties called circle theorems. So before we start, we shall go through what each part of a circle is. So one, a circle is circular, and you can see this, and the distance around is called circumference. I think I told you that under the video of area and perimeter, because what we would have called perimeter, when it's a circle, we call it circumference. So a circle is a set of all points which are equidistant from a fixed point called the center. And the circumference is the distance around the entire circle boundary. So this circle has a fixed point which is known as the center. Then when you have what we call a chord. A chord, like we saw here, a chord of a circle is a line segment joining any 2 points on the circle. So any straight line which joins any 2 points, it can be in this form, it can be here up, it can be anywhere, provides joins 2 points. But we have a special chord, and that is a chord which goes through the center of the circle. A chord which goes through the center of the circle is known as diameter. As you can see here, the diameter of a circle is any chord passing through its center. What about radius? A radius of a circle is any line segment joining its center to any other point on a circle. So you'll come here and say, if there is a straight line which starts from the center and reaches the circle, we shall call the distance will be radius. And here the distance is called diameter. Then we have what we call a tangent. A tangent to a circle is any line which touches the circle in exactly 1 point. I think you saw a chord, it was touching the circle at 2 points. But if it touches at only 1 point, then it becomes a tangent. Okay. Now we shall go to arcs. So we have a chord, and that whole part is known as a segment. But there are 2 kinds of segments. So this one, the big one, is called major segment, and the small one is called a minor segment. Same applies to the arcs. The upper one is known as the major arc, and the down one is known as the minor arc. And here we said an arc of a circle is any continuous part of the circle. So basically those are some of the terms which you need to know under circles. And now that we know them, we can go through the theorems. Theorem 1 is about angle at the center. So these theorems will involve the fact, what you need to know, and how to identify that property. So what you need to know about the theorem and how to identify that theorem. So the fact is about this theorem of angle at the center is that the angle at the center is twice as big as the angle at the circumference made by the same chord or arc. There's a property. Then how do you spot it? You start with 2 points. So you come and get your circle, start with 2 points. They could be a chord or any points. For example, if this was a chord, you would have started with this and this. But whenever there is no chord, it is still start with 2 points. Then they said, if you go point, center, point. So let's do that. Point, center, point. The angle you make will be twice as if you go point, circumference, point. So this angle you make here will be twice the angle you would have made if you had gone point, circumference, point. So you can come and say that if that is A, then this other angle will be B, and the relationship is that A is twice B. So that is about angle at the center. Each time you realize that this is the center of the circle and this is the circumference, then the two angles have that relationship, that the one at the center is twice as big as the one at the circumference. Then theorem 2 is about angles in a semicircle, and the fact is that the angle made at the semicircle, at the circumference in a semicircle, is a right angle. Now, why do we say semicircle? It is because a semicircle has diameter, meaning that the chord we would have used goes through the center of the circle. And now to spot it, look for a triangle whose base is the diameter of the circle. So if I have a circle and I have a triangle whereby the base is the diameter of the circle, do you see this? This is the base of the triangle, but this is the diameter. It implies that the angle at the circumference in this triangle will always be right angle. So this is circumference, and this angle will always be 90, provided the base of the triangle is a diameter. So you can come and do that. So this theorem is just a special case of theorem 1 because the angle at the center when you have a straight line is 180. For example, you see this angle is 180, meaning that this should be half, and half of 180 is 90. So it is just an extension of theorem 1. Theorem 3 is about angles in the same segment. So the fact is that angles in the same segment of a circle are equal to each other. Now, how do you spot it? Start with 2 points like we did at theorem 1. So I'll come and start with any 2 points. It could be a chord. So let me use a chord. Then they said, if you go point, circumference, point. So point, circumference, point. Let's do that. Point, circumference, point. The angle you will make, which is this A, is the same as if you go point, circumference, point, as long as you stay in the same segment. So point, you go to any other circumference, point. So let's do this. So in that case, it implies that angle, this angle is equal to that angle. Okay. Then we shall go to theorem 4. Theorem 4 is about cyclic quadrilateral. And the fact is that the opposite angles in a cyclic quadrilateral add up to 180. Cyclic means the four-sided polygon is inscribed in a circle. So how do you spot it? Look for a four-sided shape with each of the corners on the circumference, in other words, which is inscribed. So I'll come and get my circle, and let's draw the four-sided polygon. Okay, the opposite angles in this shape will always add up to 180 degrees. So if I have this angle and that angle, when I add them, I must get 180 degrees. Similarly, this angle is opposite to that angle. So when I add them up, I must also get 180 degrees. So note, just like any other quadrilateral, the sum of all interior angles is still 360. I think we saw that under the video, under the lesson of angles and properties. So when you add all these ones, we must get 360 degrees. So now we shall go to theorem 5. Theorem 5 is about tangent. So the fact is that the angle made by a tangent and the radius is a right angle. How to spot it? You remember that the tangent is a straight line that only touches a circle in one place. So if you have a circle and you get a line that only touches the circle at one point, then that is a tangent. And if you draw a line from that one place to the center, then the angle you form is always right angled. That is theorem 5. Then theorem 6 is about alternate segment theorem. And the fact is that the angle between a tangent and a chord at the point of contact is equal to the angle made by that chord in the other segment of the circle. It's a little confusing, but let's see how we can spot it. One is that look for a tangent and a chord meeting at the same point. So if we carve a circle, we have a tangent and we have a chord, but this tangent and this chord meet at the same point, then the angle they make will be A. What's about that angle? It says the angle they make, which is this, is exactly the same as the angle at the circumference by that chord. So by that chord means you come at this chord, draw an angle at the circumference. Like that. So this angle they make is equal to this angle at the circumference by this chord, which has a point of contact with the tangent. Okay, now similarly, remember here we measure this, we use this angle and this as the chord. What if it is the other way around? We have this tangent and we have this as the chord. It still we realize that it makes an angle to the circumference, which is this. So you come and say that if we have this as the angle, it means that this is the angle at the circumference by this chord, and therefore also these two are equal. And that was theorem 6. Now theorem 7 is about two tangents. So the fact is that from any point outside the circle, you can only draw two tangents to the circle, and these tangents will be equal in length. How do you spot it? Look for where the points of a circle meet. Then the length between where they touch the circle and the point at which they meet will always be the same. So if you have a circle and we have a point, then drawing two tangents, you can only draw two tangents from that point. One will be that meeting the circle at A, another will be that meeting the circle at B. So these distances will always be equal. Okay, but we have a note here that more often than not, This theorem leads to some isosceles triangles, so be on the look. So isosceles triangles, because this is also radius, this is radius, meaning these two sides are equal. And also that means that if I draw a line, I'll get this as a triangle isosceles and this is a triangle isosceles. Then we shall go to the last theorem, which is theorem 8. Now this theorem 8, actually in your O-level syllabus you will not cover it, because in your O-level syllabus you cover theorem 1 to 7, but we added this theorem because of the math contest and math Olympiads. So we have a theorem about touching circles, which is very, very vital. Actually, it is the most vital because most of the questions of circles will involve touching circles. They can either touch two circles touching or a circle touching another figure like a square and like that. So this theorem is the most important one. And the fact is that touching circles have a common tangent at their point of contact. And hence, two things arise. One, the line joining their centers passes through the point of contact. Okay, and two, the distance between their centers is equal to the sum of their radii. So this, like I told you, this is the key, very important in math contests. So the key to solving problems involving touching circles or a circle touching various lines is to join up relevant points. Join the center of touching circles and join the center of a circle to a point of contact of a tangent and mark a right angle. So they hide it, but each time you see touching circles, just know that there is this theorem. And the theorem says that if you have two circles, circle A and circle center A and circle center B, and you join the two centers, then the distance AB is the sum of the radius. And also they have a common tangent. Those are the two things you need to note here. And they are very vital. So with that, we shall go through I'll leave you with an assignment 4. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on solution to assignment 1. So if you have not yet subscribed, please click on the subscribe button to this video so that you can receive updates when the next video has been uploaded. uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so they can all benefit as a family. Hello viewers, we're gathering taking you through the story for O-level math contest practice. And this video we are going to go through the solutions to the Intermediate Mathematics Olympiad Assignment 1 for the year 2023. So this Assignment 1 is the same assignment which was left in the video for angle properties and polygons. So if you have not yet watched this video, I encourage you to go to the playlist and watch this video, go through this assignment so that you can come back and watch this video for solutions, then mark yourself where need be and make corrections where need be. So question 1 came from the I am okay. I think by now you know what this I am okay means. For the year 2004, question 1 from the paper of Kylie, and it says the star octagon shown in the diagram is beautifully symmetrical, and the center of the star is at the center of the circle. So this was supposed to be star. If angle NAB is 110 degrees, how big is angle ANB? So NAB is this angle and ANB is this angle. So we know that NA is 110, meaning that all these other angles will be 110. Then because of angles at the point, it implies that this will be now 250. 250, remember, angles at the point, we saw it under the video of angles and polygons. And we said angles at the point add up to 360. So when you add this, and this must be equal to 360. But the angle they want is this x. The good thing it is x to the same value throughout. So that means that we shall remember that for an octagon, it has an interior angle sum. And when you add all these angles inside, we shall come up with the value of x they want. So come and add up all those values. So the 250s, they are 4. That's why you see here 4 times 250. Then the x, they are also 4. 1, 2, 3, 4. That's why you see here 4x. When you add up, you come up with the interior angle sum, which is 1080. So next is to simplify. This gives you 100, and then take 100 this side to come up with 4x equal to 80. Divide both sides by 4 to come up with 20. Therefore, the angle will be 20 degrees. And that's what they wanted. Then question 2 came from I am okay of 2010, paper question 2 for the paper of Kylie. It says the diagram shows a square ABCD and an equilateral triangle ABE. Square this, then equilateral triangle ABE. The point F, which is here, lies on BC such that EC is equal to EF. EC is equal to EF. Okay. Calculate angle FEB. Calculate angle FEB. So first of all, you realize that they told us this is an equilateral triangle, and the properties is that all sides are equal. That's why you see these lines, and also each interior angle is 60 degrees. Then from there, because this is a square, this should add up to 90. That's why the balance will be 30. So that when you add 30 plus 60, you get 90. Okay. Then 2, you'll come and realize that since the square ABCD and the triangle ABE share a side AB, it implies that all their sides are the same. It implies that all their sides are the same. So this side is the same as this side, is the same as this side, same as this side. Do you know what that means? It means that even BC is equal to BE. And therefore triangle BCE will be isosceles. Isosceles means these base angles are the same, so this will be the same as this. That's why you give it one unknown. And I think we can get that angle because we know this value as 30. So when I add everything, I'll come up with 180. Collect like terms, 30 goes this side, and this gives you 2x. Divide both sides by 2, you come up with 75. Now I've got the value of x, okay? So we are given in the question that EC is equal to EF. That means that triangle CEF is also isosceles. So I'll come and show that it's isosceles by putting those lines, and because this angle should be the same as here, that's why I put here x. And this other one will be capital Y. And the good thing, I know the value of x, so I can easily get the value of y. So I'll come here and say that for triangle CEF, add everything, we'll get 180. Substitute for x and make y the subject. Therefore, the required angle was 30 degrees. As simple as that. Then question 4 came from IMOK of 2006, question 3 of Kyrie. It says, in the diagram, rectangles ABCD and AZXY, ABCD, then AZYX, are congruent, similar, and they are equal. And angle ADB is 70 degrees. Angle ADB. So this angle is 70. Find angle XMB. XMB. They want this angle. This angle here from here up to here. So now our interest is this part here, and that's what you're going to extract out and enlarge. And you realize that when you enlarge that, the angle they want is an exterior angle. That is why I'm getting all these exterior angles. That's why I've elongated them so that I can get all the exterior angles. Then I remember that exterior angles add up to 360 degrees. But also, if you use the interior angles, you'll get the answer, as you shall see. But let's start with the simplest, which is exterior angles. So ADB is 70. So come and put 70 here, meaning the balance will be 110 to make 180, which is sum for angles on a straight line. Then this word congruent, do you know what it means? Congruent, it means that angle ZXA is equal to angle ADB. So these angles will be the same. Why? Because the rectangles are the same and both these are diagonals, meaning also they have the same length. Therefore, this should be the same as this. Therefore, I'll come and put 70 here and the balance 110 there. Here I put 90, I think you can see it, it is 90. Then the angle they want, I called it A. So when I add all the exterior angles, I can simplify and come up with the value of A. And that's what they wanted. But also, what if a student chose to use interior angles? You still get the same answer, because interior angles, for it, you are going to first get the value of B. So simplify and get the value of B. Then use angles on a straight line to get the value of A. So you first remove the diagram and come and say for angles on a straight line, A plus B is 180, therefore the value of A will be 50. So you get the same answer either way. Then question 4 came from I am okay of 2008, question 3 of Kyrie, and says, in the rectangle ABCD, the midpoint of AB is M, and ratio AB to AD is 2 to 1. The point X is such that triangle MDX is equilateral, with X and A on the opposite sides of the line MD. Find the value of angle XCD. Now here they didn't give you a diagram, and it is up to you to use the knowledge of what you know to come up with the diagram. First, it was a rectangle, so you shall come and draw a rectangle. Then what you should realize is that the labeling is anti-clockwise and in order. So you can't say A, then you put C here, then you put B here, then you put D here. It is not okay. You have to follow the order given in an anti-clockwise direction. Now, AB is the longest because of this ratio. They said AB to AD is 2 to 1, meaning AB is twice AD. So they told us that M is a point on, they talked about M. M is a point, is the midpoint here. M is the midpoint. So this M divides AB into 2. Do you know what that means? It means that, remember, this AB was twice AD. So when this M divides, it means that AM is equal to MB and is also equal to AD and is also equal to CD. That's what it means. So they told us an equilateral triangle. They said MDX is an equilateral triangle. Remember, equilateral triangle, each interior angle is 60 degrees. So you come and draw DM, then you measure 60 degrees, you draw MX, then you also measure 60 degrees and you draw DX. So you have located our point X, okay? With X on the opposite side, because the A is this side, the X will be on the opposite side. That's what they mean. If it was on the same side, then the triangles will come in this form, by the side opposite sides. Then they said, find the value of angle XCD. That means that we're going to join those X and C, so that we can easily get that angle which they want. Okay, now how can we get that angle? One, we should remember, like I told you, that this side is equal to this side, and also this side is equal to this side. But let's start with these two. It becomes an isosceles. And because it's an isosceles, and this is 90, this will be 45, 45. Then also this side is an isosceles now. So because of an isosceles, and this is 90, this will also be 45, 45. Then the balance of this will be 45. That's why you put 45 there. Okay. Now, there is something you should realize. If this is the midpoint, it implies that this distance must be the same as this distance, because these are similar triangles. So when we put that, it implies that this triangle is also isosceles. Isosceles means the base angles are the same. So if I put here X, it will be the same angle here. Okay. Now, how can I get, my aim is to get the value of A, but I can't just get it straight away. So what I'm going to do, and I saw inside this triangle there are two unknowns. So what I'm going to do, I'm going to use angles on a straight line here and add up all these angles, equate them to 360. In that way, I'll be able to get the value of B. So I'll come and say, consider angles at M. All of them add up to 180. Simplify and get the value of B. Okay, now after getting the value of B, I can use this isosceles triangle to get the value of X. So using the isosceles triangle, X plus B is 180, meaning that 2X will be 150 and X is 75. Now after getting this X, I realize that this X is the sum of A and 45. Therefore, X is equal to A plus 45, substitute for X and to get the value of A. And basically, that is what they wanted. Question 5 came from I Am OK of 2006. Question 2 of Hamilton. And it says, the diagram shows a triangle and two of its angle bisectors. What is the value of X? So this means these angles are the same and these two angles are the same. So I'll say, let's just put A here each, and also here we put B each. Then shall come and there are now two triangles. When I start with a smaller triangle, adding all the angles gives me 180. And that is equation 1. Then bigger triangle, adding all the angles gives me 180. Okay. Now, the knowledge I'm going to use from this step is called the knowledge of simultaneous equations. And it was already covered in week 1 for algebra. So my work is to eliminate these two because I want the value of X. To eliminate these two, you realize that here there is 2, meaning that I have to multiply 2 throughout equation 1. So 2 throughout equation 1 and subtract. We are subtracting because these are same sign. If there were different signs, we would have said add. So when I do that, I realize that this goes away, this minus this is 3x, and this minus this is 180. So divide both sides by 3, you'll come up with the value of X which they wanted. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on solutions to assignment 2. So if you have not yet subscribed, please click on the subscribe button below this video, and also if you know any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that you can all benefit towards a family. Hello viewers, Wagadaruna taking you through the story for O-level math contest practice. And this video I'm going to go through the solutions to the intermediate math Olympiad assignment 2 for the year 2023. So this assignment was left in the video which was covered in day 2, and that was the video of Pythagoras theory. So if you have not yet watched it, I encourage you to first watch it, attempt the assignment, then you can come back to this video and assess yourself. Question 1 came from I Am OK of 2004, question 3 of Kylie, and says, a quadrilateral ABCD has sides AB, BC, DC, DA of lengths X, Y, Z, and T, respectively. The diagonals SC and BD cross at right angles. prove that x squared plus z squared is equal to y squared plus t squared. So here the good thing, they told us that the diagonals cross at right angles, meaning there will be some Pythagoras theorem. So let O be the point of intersection of the diagonals. And to make life simpler, begin with drawing the diagonals and make sure they are perpendicular. Then you can join the points to get the quadrilateral. Then you can label in an anti-clockwise direction. Then you come and remember that AB is X, BC is Y, DC is Z, and AD and DA is T. So come and substitute. Then from there we shall let the lengths, because we need these sides for us to use Pythagoras theorem. So let the lengths OA, OB, OC, and OD be these ones. So we shall come and add them there. Then we can now use Pythagoras theorem for each of the right angle triangle. So for the first one, x squared is equal to a squared plus b squared. Then second one, y squared is equal to b squared plus c squared. Third one, z squared is equal to c squared plus d squared. And fourth one, t squared is equal to a squared plus d squared. Now when you have those ones, we shall remember what they told us. X squared plus z squared. So I'm going to add this to this and I see what I get. So let me come here and add the two. When I add, I'll come up with that. Okay. Then we go back. They also told us, what about if you add y squared plus t squared? This plus that, which is equation 2 plus equation 4. What will I get? So when I add, I'll come up with that. Do you realize something? That this one gives me a squared, b squared, d squared, and c squared. Even this one gives me a squared, b squared, c squared, d squared. Meaning that both of them are equal to this. And because both are equal to that, it implies that they are also equal. And that's what they wanted. Question 2 came from I am OK of 2009, question 4 of Kyrie, and says, in the rectangle ABCD, the side AB has length √2 and the side AD has length 1. Let the circle with center B and passing through C meet AB at X. Find angle ADX in degrees. So we shall come and first sketch our rectangle. Then remember that labeling is anti-clockwise. And the side AB is √2 and AD is 1. Then they told us about a circle with center this and passes through C, meaning the radius is BC. Okay. Then they said find angle ADX. ADX. ADX means we shall draw a straight line from D to X and let that angle be X because we don't know it. Then the other angle to complete a triangle will be Y, but because of alternating angles, this Y is the same as this angle here. So both BX and BC are the radius of the circle, implying that BCX is isosceles. This angle, this is isosceles. When it is isosceles, it means the base angles are 45 degrees. And here the balance will be 45. And the remaining angle will be Z. Let's call it Z. Okay. Now our work is to get the value of X. And how can we get the value of x? So we're going to first use Pythagoras theorem for triangle BCX to get this length here and see if it can help us. So if I use that get that length from Pythagoras theory, come and substitute, simplify, and get CX. CX is root 2. And there's something funny. This CX and this CD, just notice something? They have the same length, meaning this triangle is isosceles. Triangle CDX is isosceles. And because it is isosceles, it implies that these base angles are equal. Y is equal to Z. So let's use that logic to come up with something. So for triangle CDX, the angles add up to 180, but Z is equal to Y, meaning I can get the value of Y. When I get the value of Y, it implies it's the same value of Z. So Z is also that. Okay. Now that I've got the Y, I can go back and say that in this right angle triangle, when I add all these angles, I should get 180 degrees. So come here and add. Substitute for Y and get the value of X. Therefore, that's the angle they wanted. So now shall go to question 3, which came from IMOK 2009, question 3 of Hamilton. And it says, in the diagram, ABCD is a rectangle with AB equal to 16 and BC equal to 12. Points E and F lie on sides AB and CD so that ACEF is a rhombus. This is a rhombus. What is the length of EF? Length of EF. Okay. So they told us AB is 16 and BC is 12 because this rectangle, this angle is 90. Then they told us that this is a rhombus, AECF. So this is equal to this and this is equal to this, and they are 90 degrees apart because it's a rhombus. Now here, there are many right angles which we are going to use. But the first one, okay, let the sides of the rhombus be x. That means that AE is x and EB is 16 minus x. So is what I told you, because this is a rectangle, then this angle is 90. So now we are going to use Pythagoras theory for triangle ABC. In that case, AC is equal to AC squared is equal to AB squared plus BC squared. So substitute, simplify. When you add the 2, you come up with that, then get square root. And that will be the value of AC. So AC, we have got AC as 20 centimeters. So next is now to use triangle EBC. So when you come here, EBC, this is EC is the hypotenuse. So AC squared is equal to EB squared plus BC squared. So let's come and do that. But we know that EC, the hypotenuse is x. And this one is 16 minus x, so x squared is equal to 16 minus x. Use brackets very well. Squared plus 12 squared. The good thing, we learned how to expand perfect squares. So by saying the square of the first entry minus twice the product of the entries inside the bracket plus the square of the last entry. think you remember that. Under algebra of week 1, then this squared is that. So simplify, this gives that, this gives that, this gives that, this is that. Then you realize that this and this can cancel. And also this with this can add up to 400. Then take this side to become positive and divide both sides by 32 to get 12.5. Now that I have the value of x, I can go and use Pythagoras theory for triangle FOC. Now FOC this is FOC, and because this is a rhombus SCEF, it implies that this side is equal to this side and is equal to this side. So CF is already x, which is 12.5, which I've got. Then OC is half of SC. Then FO can be got, but that FO, the good thing is that FO is half of FE, which they want. So in the end, we shall get what they want. So we are going to come here and say FC squared is equal to OF squared plus OC squared. Then I remember that OF is half of EF, and EF is what they want. Then OC is half of SC, and SC I already got it. Therefore, I come and substitute for FC. Then this one, the square is on both, so a squared, half squared is a quarter, and this squared gives you that. Then SC is 20. Then simplify, this gives you 100. Then correct like terms, take this on this side to come up with this. Then cross multiply, take this on this side to come up with that. Then put square root and get the value of EF, and that's what they wanted. Then question 4 came from I Am OK 2003 question 2 of Hamilton, and says a quadrilateral ABCD. In quadrilateral ABCD, AB is 1 centimeter, CD is 2 centimeters, AD is 3 centimeters. Angle BAD is equal to angle CDA and is equal to 60. The good thing they have shown it in the diagram. Calculate the length of side BC. Now here it is a little funny, but we shall do it. So first, let me first redraw it here. Now, because this is 60 and this is 60, we can generate an equilateral triangle by putting here midpoint E, so that this is also 2. So if this is 2 and this is 2 and this angle is 60, it implies when I join, I'll come up with an equilateral triangle. Same applies to this 1, 1, 60, meaning that when I join this to this, I'll come up with an equilateral triangle. Let's start with the big one. Shall put there 60, throughout, and here 2. Then the small one shall put here 60, 60, and here 1. So I've now got 2 equilateral triangles. But these are angles in a straight line, meaning that if this is 60, this is 60, this one should also be 60 to make the 180 degrees. Okay. Now from there, there's something you can realize about this. I think we covered it about in Pythagoras theory. We covered particular right angles for right angle triangles for particular angles, and you said if there is 60 here and this side is half this side, then this should be right angle. So that was the trick I wanted you to identify. So triangle that is a right angle at B. Why? Because this is 60 and this side is half this side. So using Pythagoras theory for that right angle we have got, we can, let me first rub off this and then we code the Pythagoras theory, substitute, simplify, collect like terms, get square root, and that will be the answer they wanted. Then question 5 came from I Am OK of 2008, question 5 of Kyrie, and says, a kite has sides AB and AD of length 25 centimeters and sides CB and CD of length 39 centimeters. The perpendicular distance from B to AD is 24. The perpendicular distance from B to CD is h. Find the value of h. So here we have to, when you see these right angles, just know that there should be Pythagoras theory somewhere. So what we are going to do, we are going to call this point x, so this, and let this distance, this small distance, be small x. Then that one be 39 minus x. Then for this one, that will be small y, and here it will be 25 minus y. Now here, if I join from B to D, I realize that I'm going to get 4 right angle triangles. This is a right angle triangle. This is a right angle triangle. This is a right angle triangle. And this is a right angle triangle. So all those triangles will be used in one way or another to come up with the value of h which they want. So let's start with this one. You realize that given this ratio, remember we talked about Pythagorean triples. So someone would say that if from this Pythagorean triple, if this is 25, this is 24, then this should be 7. It will still be okay. Now, because it was not easy for you to realize this, then the only option was to use Pythagoras theory. Now, when you use Pythagoras theory, we shall come and state it, substitute, simplify, collect like terms, and get square root. And that's how we could come up to 7. But either way is okay. So now we have got this value of 7, meaning that we know this, and therefore we shall now come to this right angle triangle and get this hypotenuse BD. So Pythagoras theory for BDY, we shall come and state it, substitute, simplify, add the 2 and get square root and get the answer. So BD is 30. Now we have got BD. So next is to go to this triangle BDX. So for BDX, we have that, then substitute. So that will, this one has 2 unknowns, so we are going to first call it equation 1. Okay. Then we go to triangle BCX. BCX, we have that, substitute. Then we are going to expand. This is expanding perfect squares. We learned it under the video of expansion of algebraic expressions. I believe by now you know where it comes from. Then you simplify. This is that, this is that, this is that. So you realize that this and this can cancel. When they cancel, you remain with that. Then that means that when I rearrange, it becomes this. Now, these are 2 equations and 2 unknowns, so you have to solve simultaneously. What you realize is that this and this are the same. Did you see that? Therefore, I can use the method of substitution and say substituting equation 1 into 2. So where there is this, I'm going to put there 30 squared. Then simplify and divide both sides by 78 to come up with 150 over 13. So I've got the value of x. Now we can get the value of y. If I have x here, I can substitute for x and get the value of h. So I'll come here and say that from equation 1, that's what we have. Substitute for x. Then take this on this side. Difference of two squares means one bracket is sum, another one is difference. So the one of sum gives this, the one of difference gives that. So when I multiply the one up, I'll come up with this. The one down come up with 13 squared. So when I put a square root, I come up with 360 over 13. And I can get that if I use a calculator. But in Math Olympiads, a calculator is not necessary. So it is better you leave it like this. And actually that is why from here we went to difference of two squares. Otherwise from here I would have used the calculator to come up with this. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on assignment 3. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family. Hello viewers, Wagdaru now taking you through the story for O-level math contest practice. And this video we are going to go through the solutions to the intermediate math Olympiad assignment 3 for the year 2023. So this assignment 3 was left behind in the video of day 3, which was under area and perimeter. And today we are going to go through its solutions so that you can easily mark yourself and make corrections where necessary. Question 1 was from I Am OK 2006 paper 2006 question 1 from Kyrian. Says a rectangular piece of paper is cut into two pieces by a straight line passing through one corner as shown. So this is a straight line. Given, so this is n. Given that area x is the ratio of area x to area y is 2 to 7. Area x to area y is 2 to 7. What is the value of the ratio a to b of these sides a to b? So one, you realize that this is a shape of a triangle which is right angled, and this is a shape of a trapezium. So my question, so what I have to get is, what is area x? So area x is the area of a triangle which is a half base times height. Therefore let L be the length of the rectangle from here to here. Therefore region x is a triangle and region y is a trapezium. That means that area x will be a half base times height. A half this a times L. Remember we said this is L, which gives you half a L. Then area y is a trapezium. A trapezium is a half times the height. Now in this case, these are the parallel sides. I think you remember the formula of area of a trapezium. So this will be the distance between the two parallel sides, and that is L. Okay, then in brackets we put the sum of the two lengths of the parallel sides. So we put the sum of a of b, which is here, and the sum of from here up to here, which is a plus b. And when I collect like terms, this and this gives me 2b, which is here. Now I've got area x and area y. Then I remember that their ratio is 2 to 7. So I'll come and say that ratio is that. And we know that this one in ratio form is the same as fraction. So I'll come, let me first rub off that and put in term form of fraction. Area x over area y is equal to 2 over 7. Then from there I can cross multiply. When I cross multiply, I'll come up with 7 times area x is equal to 2 times area y. Then I remember that area x is this and area y is this. So where there is area x, put there that. Where there is area y, put there that. I'll come up with that. Now from this, I realize that 1, something will cancel. A half is going to cancel. Then also the L will cancel. Now the question is, what will I be left with? This side I will be left with 7a, and this side I will be left with 2 in brackets a plus 2b. Now here I have to open this bracket. So when I open bracket, I'll come up with 2 times a, which is 2a, then 2 times 2b, which is 4b. Okay, now from that step, I realize that there's a and m, so I have to collect like terms. I'll bring this one this side to become 5a. Okay, now my aim is to get a ratio of a to b, and the ratio of a to b is the same as a over b. Now from this step, if I want to get a over b, do you know what I'll do? I'll need to take this to bring this b this side. So when I bring this b this side, it becomes a over b. Then also take this 5 this side to become 4 over 5. I don't know if it's understandable, but what you have done, this is what you have done. 1, to take b this side, I divide both sides by b. So when I divide both sides by b, I'm going to come up with this over b is equal to 4, because the b will cancel. Then from there, I don't need this 5. So I'll again divide both sides by 5 to get here 5, then also here 5. You realize that this 5 cancels and remain with a over b equal to 4 over 5. Then from there, I can now state the ratio they want, and that would be the required ratio. Then question 2 came from IMOK of 2005, question 3 of Kylie, and says, in triangle ABC, angle B is a right angle, it is here, and X is a point on BC, so that BX, the ratio of BX to XC is 5 to 4. Okay. Also, the length of AB is 3 times the length of CX. And the area of the triangle CAX, CXA, that area is 54 centimeters squared. Calculate the length of the perimeter of the triangle CXA. So remember, perimeter, you add all the sides. So as we are calculating, we have to get the length of this side, the length of this side, and the length of this side. So let's start. 1 is to use the given ratio. So from this given ratio, it implies there is a positive number k such that bx is 5, that number which is 5k, and xc is 4k. Now me, I've chosen to use k. You can choose to use another letter. You can say let the letter be y, so here it will be 5y and 4y. Others can choose to use w, so here it will be 5w and 4w. So for me, I've chosen to use k. That means that bx is 5k and xc is 4k. So bx 5k, xc 4k. Then we shall go the next. Also, we are given in the statement that the length of AB is 3 times the length of CX. Now that we know CX, it means that we can get the length of AB, which is 3 times CX, and we'll come up with 12K. So now this length is 12K. Okay, this is 12K. Then proceed. Then we are also given that the area of the triangle CXA is 54. And we know that area is a half base times height. So in this case, for this triangle, the base is this CX and the height is this AB. Then we shall come and say that area is equal to a half base times height. Then you can come and substitute. Area was 54, base is that, height is that. Now from there, I realize that I have only one unknown which can be got. Now let me simplify. When I simplify, a half times 4 is 2, 2 times 12 is 24. Then k times k is k squared. Okay. I still want to make k the subject, so I'm going to divide both sides by 24 to come up with, so 54 over 24 gives you 2.25. Okay, but this is still k squared, so I have to put square root on both sides. So k will be square root of 2.25. From here, I have to use a calculator to come up with 3 over 2, or 1.5 as the answer. Now I've got the value of k. Do you know what that means? It means I can now get the actual lengths. But before that, we are going to say, for the right-angled triangle ABX, remember we saw that BX is 5K, AB is 12K. Now this is right-angled. Let's look at it. ABX, this triangle is right-angled, and we know the length was 12K, 5K. Now this one, when you see 12 and 5, what should come in your mind is a Pythagorean triple, because we have a ratio of 5 to 12 to 13. I think you remember that. We saw it under the video of Pythagoras theory. So that means that AX will be 13K, because 5 has been taken, 12 has been taken, so what is left is 13, which will be for AX. Now, I've chosen to use Pythagorean triple, but even if you use Pythagoras theorem, you still come up with this value. So Pythagorean triple is there to make life easier. What about for triangle, right-angled triangle ABC? We have AB as 12 and BC. Let us first look at this triangle. BC is the same as BX plus XC. That's what I'm saying here. BX plus XC to give you 5K plus 4K, which is 9K. Okay. Now, when I see this 12 and this 9, something comes to my mind, and that would be a Pythagorean triple of ratio 3 to 4 to 5. Do you know why? Because if I multiply this ratio throughout by 3, this will become 9, this will become 12, and this will become 15. Now for me, I have 12 and 9. So 12 is taken, 9 is taken, so the remaining part should be 15. Now, like I told you, Pythagorean triple is there to make life easier. But if you forget these ratios, then you have to go back and use Pythagoras theorem. Now that means that the length of the perimeter is equal to CX plus XA plus CA, which is 4K, 13K, 15K, which gives you 32K. But the good thing, I know the value of K, so I'll come and substitute for K and get the actual perimeter. And that's what they wanted. Question 3 came from IMOK of 2007. Question 3 of Kyrie and says, the diagram shows a square ABCD of side 10 units. Line segments AP, HU, AR, and AS, which are these ones. Divide the square into 5 regions of equal area. Note this word, equal area. Calculate the length of QR. Okay. So first of all, we are going to see that the total area of the square is 10 squared, because 10 is the side, to give you 100. Now, because there are 5 equal areas, I'm going to divide by 5 to get the area of each, which is 20 square units. Now, considering the area of ABP, this one, we already have the height, but we don't know that the base is BP, we don't know it. But the good thing, we know that the area is 20. So I will come and substitute. Area is equal to half times height times base. Therefore, I realize that BP is the only unknown which can be got, and to be 4 units. So I know now this length, which is equal to this, and equal to this. So since the triangles, these have the same area and same height, it implies that they also have the same bases. That means that BP is equal to PQ is equal to DS equal to SR, which is 4 units. Okay, and that implies that these other ones, QC and CR, are equal to 2 units. So using Pythagoras theorem for that triangle, remember the one, the length of QR. So I come and substitute for QC and CR. Could simplify, put square on both sides, and this will be the length needed. Then question 4 came from IMOK of 2010, question 4 of Hamilton, and it says the diagram shows a quarter circle with center O and 2 semicircular arcs with diameters OA and OB. Calculate the ratio of the area of the region shaded gray, gray is this region, to the area of the region shaded black, which is this. So one shall say that let the radius of the semicircle be R. That means that the radius of the quarter circle is 2R from here, because diameter is twice radius. So we shall come and put there 2R and 2R as the radius of the quarter circle. So this diagram is divided into 4 regions. So let their areas be X, Y, Z, and T. So we shall come and put X, Y, Z, and T to denote the areas. So the area of the quarter circle of the whole of this is a quarter times pi times the radius, but this time the radius of this quarter circle is 2R. That's why you see 2R squared. Open brackets will come up with pi R squared. Then the area of each semicircle is a half pi R squared. So that, what does that mean? It means that, remember, each semicircle, let's say, for this semicircle, it encloses 2 parts, which is y plus z. So y plus z will be half pi R squared. Then also for this semicircle, it encloses z and x. So z plus x will be half pi R squared. That's where this statement is coming from. Then the area inside the quarter circle, but outside one semicircle, is, so area inside the quarter circle. For example, if you look at this, the area inside the quarter circle but outside, For example, if this is the semicircle of interest, the area outside this semicircle will be y plus t. Okay. Similarly, if we take this as a semicircle of interest, the area outside will be x plus t. And their areas each will be given by, so you can say that area inside the quarter circle but outside the semicircle is equal to area of the quarter circle minus the area of the semicircle. You remain with a half pi r squared. So what does that mean? It means that y plus t is a half pi r squared and x plus t is equal to a half pi r squared. I think we saw that. Now from there is something we are going to realize. Do you know that? This is what you are going to realize. This area, do you see that it's somehow equal? Actually, it's equal. What about this? It is also equal. That means we can now equate the two. So by comparison, it implies that yz is equal to yt because they are all equal to a half pi r squared. When you do that, you will realize that this y cancels and remain with z equal to t, which is here. That is one way. If you chose to use this, still choose the same because these are the same area. So you would still say that this is equal to this, then x cancels to end up with z equal to t. So either way is okay. Now what does that help us? That one means that the areas of the shaded regions are equal, and hence the ratio of the regions shaded gray to area of the region shaded black is 1 to 1. Question 5 came from IMOK 2010 of question 5 of Macron, and it says the diagram shows a rectangle divided into 8 regions by 4 straight lines. 3 of the regions have areas 1, 2, and 3 as shown. What is the area of the shaded quadrilateral? So I'll come and first label them. They want the area of this shaded part. So let me first label the rectangle and also label each region, because they had only given us this, this, and this. So others will label them with unknowns. But the aim, at the end of it all, they want the value of b, because that is the area of the shaded region. So you come and see that from the above diagram, triangles ADF and CDE can be got with each having the same base and height of the rectangle. Now what is triangle? Let's see, analyze this triangle ADF. You are going to realize something. This is what you are going to realize. The base here of the triangle is the side with this side width of the rectangle, and also the height of that triangle is also the length of the side. What does that mean? It means that the area of this triangle is half the area of the rectangle. And when it is half, do you know what it means? It means that this shaded part, the area of this triangle, is equal to the area of the remaining parts. Okay, then similarly, if I look at triangle CDE, still the same thing. It has this base which is equal to this length and this height which is equal to this length, meaning the area of this triangle is half the area of the rectangle, implying that the area of the triangle, this part shaded green, is equal to the area of the remaining parts of the rectangle. So that is the trick, that was the trick behind this question. And if you realize it, then it will be easier. So let's start with that triangle ADF. So that's what I've been explaining, meaning that the areas will be equal. So for triangle ADF, the area of ADF is equal to the remaining area outside ADF. That means that this plus this plus this is equal to A plus 1 plus 3 plus C plus 2. So let's come and write it. Then collect like terms, because 3 plus 2 plus 1 gives you 6. So we'll come up with equation 1. That was triangle ADF. What about triangle CDE? So let me first remove this and we go to triangle CDE. For triangle CDE, still the area shaded is A plus B plus C. And the area not shaded will be D plus 3 plus 2 plus E plus 1. So they should be equal. Therefore, I'll come here and say that for triangle that area CDE is equal to remaining area outside CDE. Then substitute. Then simplify, because this plus this plus this gives you 6. Okay. Now from there, the reason why I've brought this on this side is because if you look at this equation 1, we had D and E this side plus 6, meaning that if I make here D plus E the subject, I can easily substitute. So I'll come here and say that substituting equation 2 into equation 1 will give me that. So where there was D plus E, I'm going to put there the whole of this, which is that. Then I'll open the bracket and see, are there some things which can cancel? Let's look at this A. A can cancel. Okay. What about this C? C can cancel. Okay. I think that is all. So what will be left, this side will be B, and this side will be 6 plus 6, which is 12, then minus B. Now, when I collect like terms, this will go this side to become 2B. Then divide both sides by 2 to come up with 6. So that implies that the area of the shaded quadrilateral is 6. And that's what they wanted. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on solutions to assignment 4. Therefore, if you are not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. Also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family. Hello viewers, who are with Aruna, taking you through the story of O-level math contest practice. And this video, we are going to go through the solutions to the intermediate Math Olympiad Assignment 4 for the year 2023. So this assignment was left in the video of day 4, which was on circle properties. And today we are going to go through its solutions so that you can assess yourself and make corrections where necessary. So question 1 came from IMOK 2005, question 5 of Hamilton, and says the region shown shaded in the diagram is bounded by 3 touching circles. I think you remember when you are learning that video of day 4 on circle properties, I told you touching circles are very vital in these intermediate math Olympiads. By 3 touching circles of radius 1 and tangent and tangent to 2 of the circles. Tangent to 2 of the circles, and these touching circles, that's what they mean. So this is the region enclosed. There is this and also this. Calculate the perimeter of the shaded region. So the shaded region is from here to here, from here to here. You go like this, you come like that. So that is the perimeter they want. So the first thing to do when they are touching circles is to join their centers. So I'll get these centers and I'll join them. Okay, they told us their radius is 1. So do you know what that means? It means that each is 1. For A, this is 1, 1. At B, also this is 1, 1. Then at C, this is 1, 1. Okay, now realize that this side AB is 2, AC is 2, and BC is 2. What does that mean? It means that triangle ABC is an equilateral triangle. So you put 60 degrees each. Then also, this is the center and this is the tangent, meaning the line from the center to the tangent makes an angle of 90. And this is also radius, because the radius, this will be 1 like that. Even here, when I drop a perpendicular, this will be 1 and this will be 90. Okay. And this length is 2 because 1 plus 1 is 2. Now, each of the arcs DE, EF, FD, and FD has the same length given by. So DE, this arc, this arc, this arc have the same length, and the reason is because they all subtend the same angle at the center. So arc length, I think you should remember the formula of arc length, angle over 360 times the circumference to give you pi over 3. So in the assignment you handed in, some of you are substituting for pi, but it's better you leave it there unless they tell you, because pi has two ways. One can be 22 over 7, the other can be 3.14. So when they tell you, you can substitute. But still, if you substitute, if you feel you wish to substitute, then you should use the one of 22 over 7, which is more accurate. But if you leave pi in your answer, it is still okay. So each of the arcs GE and HE has the same length, this arc and this arc. For them, they subtend an angle of 90, so it makes a quadrant, which is a quarter of the circumference, to give you pi over 2. Okay, now that means that I can get the perimeter, because I know this, and this are all equal to pi over 3. And also this and this are all equal to pi over 2. Then this is 2. So when I add everything, I will get the perimeter they want, which is 2 pi plus 2. Then question 2 came from I Am OK of 2007, question 3 of Hamilton. And it says, the diagram shows 4 circles of radius 1 placed inside a square so that they are tangential. Tangential means it touches at one point to the sides of the square at the midpoints of the sides and to each other. Calculate the shaded area. So they want this shaded part, this, and that. So each time you see touching circles, just know that you need to put the centers of those circles and also join the centers. So let us join the centers. Then we join them. And when we join, we come up with a square still. Remember, the radius was 1. So that is 1. Then at B also, at C, at D. So the square is of side 2, meaning that if I want to get the area of this square, it will be 2 times 2, which is 4. Okay, now I have got this part. I've got the area of this part. The next is to get the area of this remaining part for this circle, the remaining part for this circle, remaining part for this circle, and for this circle. How do I get it? We use the area formula for getting area of a sector, because if this is 90, the remaining part should be 270. Or you can say if this is a quarter of the circle, the remaining part will be 3/4. Now this dotted line is to help us get the length of the big square outside, because we shall also need it. But for now we are interested in getting, because we know this area, now we are interested in getting these other remaining areas. So the remaining unshaded area is made up of 4 3/4 circles of total area given by 4 times 3/4 times area of a full circle. So that will give you, substitute for r to come up with 3 pi. Therefore, the total unshaded area is 4, which is area of the square, plus 3 pi, which is the area of the 4 3/4 circles. Meaning that from Pythagoras theory, I can get that length AC is equal to AB plus BC squared. So substitute, simplify, then put square root on both sides to come up with AC. So now that I've got AC, I can get the length of the side, which will be 1 plus 2 root 2 plus 1, which is 2 plus 2 root 2. Therefore, the area of the square is this squared. And when you square it, I think you remember about how to square this. You first square the first entry, then the next entry. You first get the first entry squared, then you add on twice the product of the 2 entries, which is this twice the product of the 2 entries, then you square the last entry. So that was, this concept was learnt under the video of week 1, which was expansion of algebraic expressions, and I think it was even the very first video for math contests. So collecting like terms, we come up with 12 plus 8 root 2. Therefore, the shaded area is given by subtracting big square minus this unshaded part. And that will give you something like that. Collect like terms, and that's what they wanted. Then question 3 came from I am OK of 2007, question 2 of Macrolin, and it says the diagram shows a circle of radius 2 and a square. The circle touches 2 sides of the square and passes through 1 corner of the square. The area of the region shaded black, which is this, and that region is inside the square but outside the circle, the area is X. The area of the region shaded gray, and that area is inside the circle but outside the square, the area is Y. What is the value of Y minus X? So we're going to first come and say that, this one, we are given that this is area Y and this is area of X according to this question, these parts. So what they are going to follow some rules. One, we are going to label. So label the points common to the square and the circle. So this point is common, this point is common, this point is common, this point is common, and this point is common. That is the first step. The next step, we are going to now label the remaining vertices. So there's this remaining vertex, this, and that. There's a reason why. The next, we shall now locate the center of the circle. and next we are going to join. We are going to join the line CO like that to meet AH at K. Then also DO to meet AB at L. Okay. Now these are all right angles. This is a radius of the circle, radius of the circle. It was given in the question. Now these sides, we don't know them, so we shall first call them A. But the good thing, we know that from here TR is 2, and that will be the hypotenuse of this right angle triangle. So angles this and this are right angled. Okay. Then for this equal to this and equal to 2, and for the square this, it implies that OL is equal to OA. Hence, OKAL is a square. So this one is a square. This is a square. That's why we wrote same sides, AA. So for the right angle triangle, we can use Pythagoras theorem to come up with the value of A. So simplify, put square root, the value of A is √2. Now that you have got the value of A, it means that you can get the length of the square, because if you look at this diagram, this length is the same as from here TR, and from here TR is 2 plus A, which is 2 plus √2. So if the region where the circle and the square overlap has area Z, then using the notation given, we know that area of the circle minus area of the square is equal to this. Now let's see what that means. We already know that this and that is area Y. Okay, then this and this is area X. Now this other part here, which you see, will now be Z. Meaning that Z, if I want the area of the circle, so if I put the Z, if I want the area of this circle, it will be Z plus Y. I think you realize that. Okay. Similarly, this is Z. If I want the area of the square, it should be Z plus, because this is the square, it should be Z plus X. So area of the square is Z plus X, and area of the circle is Z plus Y. That's what we are writing here. Then I'll come and substitute. If I know that area of the circle is pi r squared, then area of the square, because I know the side, it will now be this squared. Then here I'll open brackets to come up with this. So this minus here gives you negative Z, and minus and positive gives you minus. Now there is something, you realize that on this side, Z will cancel and remain with Y minus X. And good enough, they want us to get the value of Y minus X. Okay, when I expand this, I'll come up with this. I think remember that from video of expansion of algebraic expressions. Simplify, collect like terms, this with this gives you 6. Okay, so that means that when I open brackets, I'll come up with that, and therefore that will be the value they wanted. Then question 4 came from IMOK of 2006, question 4 of Hamilton. And it says, a circle is inscribed in a square and a rectangle is placed inside the square but outside the circle. Inside the square but outside the circle. Two sides of the rectangle lie along sides of the square and one vertex lies on the circle. This is the one vertex, and these are the two sides of the square. The rectangle is twice as high as it is wide. Okay. What is the ratio of the area of the square to the area of the rectangle? Now we're going to begin with this statement that the rectangle is twice as high as it is wide. Meaning that if we let y to be the width, then the height will be 2y. So we'll come and put here y and 2y. Then also let x be the radius of the circle, so that the square has side 2x, because this is the side is the diameter of the square of the circle, which will be 2x. So we have put a center there, and the radius as x. That means that if, first of all, if this is 2y, from here t is 2y, and from here t is 2x, then this, is x, then this remaining part will be x minus 2y. Similarly, if from here to here is x, and from here to here is y, then this remaining part will be x minus y. So you come and feed it then there. And the reason is for us to get a right angle triangle. And now we have managed to get a right angle triangle, we can now use Pythagoras theorem. So come and substitute in Pythagoras theorem. Then we open brackets, expanding. I think by now you know how to expand that. Then collect like terms. So now from here, collecting like terms, this and this will cancel. Then this with this will give you negative 6. And this with this will give you positive 5. So when I rearrange, I'll come up with that. Now these are 3 terms, but I need 4 terms for me to factorize. Remember the factorizing by splitting the middle term. So what I will do, I'll just split this negative 6 into negative 1 and negative 5. So that I pair these 2 and these 2. For the first 2, x is common, so remain with x minus y. For this negative 5y is common, so remain with x minus y. Then correct like terms, this and this are common, here remain with x, here remain with negative 5y. That means that either this is equal to 0 or this is equal to 0. For this one we get x equal to y, and for this we get x equal to 5y. However, x equal to y is impossible since there would be no circle. Therefore, x is equal to 5y. And when x is equal to 5y, the ratio of the area of the square to the area of the rectangle will be given by that. So let's see what that means. Why are we writing that? We are writing that because 1, when it comes to the square, remember the side of the square was 2x. So because x is 5y, it becomes 2 times 5y. And that is where this 10y is coming from. That is the side, but to get the area, you square it. That's why you see this squared. Okay. Then for this rectangle, it is okay because these are the actual sides, length times width. So we can simplify. Now this y squared can cancel, and this 2 you can still reduce by 2 to come up with 50 to 1 as the required ratio. Then question 5 came from IMOK of 2011, question 4 of Hamilton, and says a square fits within a circle which itself just fits within another square, as shown in the diagram. The ratio of the 2 shaded areas, find the ratio of the 2 shaded areas, is this and that. So we shall now come and say that let this be the length, the square, inner square be of side x, r be the radius of this, then this be called gray and this be black. Now because this is the radius of the circle and the length of this outer circle, the side of the outer circle is equal to the diameter, it implies that the outer circle is of side to R. So if I want to get the total area shaded between the circle and the outer square, the total of this area, this area, this area, and this area, I'll come up with area of the outer circle square minus area of the circle. So square is this, outer of the circle is that. Open brackets, collect like terms. But there are 4 parts, but for us we want only one part, so we have to divide by 4. So area of the black shaded region will be this divided by 4. Okay, what about this one shaded gray? We shall come and say that the 2 radii of one side of the square of this square form a right angle. Therefore, we can use Pythagoras theory to get the value of x in terms of r. So that we can come and now say that the total area between the circle and the inner square will be given by area of the circle minus area of the inner square, which is pi r squared minus x squared. But a good thing, we know the value of x squared. So come and substitute. Then collect like terms. Therefore, we can now get the ratio. So area of the gray shaded region will be this over 4. And that means that the ratio can be good. So we have chosen black to gray, but we can also use gray to black because the question did not specify the order. So to be this, then I'll remove this 4 to remain, and this r to remain with this. Then now, if you stop here, it is okay. Why did I did this? Because some of you went further. So when I will go further, substitute 20 over 7 to pi. Then you come up with this and this. Then from there, 7 will cancel, you remain with 6 to 8. Then 6 to 8 you divide by 2 to come up with 3 to 4. So you can either get 3 to 4 or 4 to 3, and it will be correct. So that brings us to the end of this video and end of week 2. Now we are going to week 3, and week 3 will be on trigonometry. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family. Hello viewers, so Wagodaruna is taking you through the story of O-level math contest practice. In this video, we're going to go through the topic of trigonometry part 1. So this video is suitable for students in senior 1 and senior 2 with passion of one day participating in the national math contest and thereafter math Olympiads. So this will be the program for the 6 days of this week. So in this video, I'll leave you with an assignment 1. Now in trigonometry, there are some letters, Greek letters, which we usually use to denote angles. If you see this symbol or this letter, just note denotes, it means alpha. So when I speak alpha, it means it is this letter. When I talk about beta, it is this letter. When I talk about theta, it is this letter. Phi, it is this letter. Sigma, it is this letter. So I can use any of these to denote angles So our topic today, the first part is about labeling sides of a right angle triangle. Now remember, under Pythagoras theory, there's something we said. We said these are the legs of the right angle triangle. But now we shall give them a special name. We shall give each leg a special name. So for a right angle triangle with angle theta, mean that if they have given you an angle, remember previously in Pythagoras theory, we didn't mind of the angles inside the triangle. What we only minded of was this right angle triangle. The angle here was not minded about. But now, when they give you one angle inside the triangle, then you can use that to label the sides of the legs. So the longest side will always be the hypotenuse. But these other sides will change based on where the angle is. So the other sides, one is called opposite and the other one is called adjacent. Now the opposite is this side opposite the angle theta. So if you look at, so in this case they are given this angle, meaning that the opposite is this. So you shall come and say that that is the opposite, and meaning that the remaining side is what we call the adjacent, because the triangle has three sides. So when you're labeling it, first label the hypotenuse, followed by the opposite, and the remaining part will be called the adjacent. So those are the sides of a right angle triangle. Previously we just called them these sides legs of the right angle triangle, but now we give them a special name now that we know an angle inside the triangle. So those sides opposite and adjacent are named based on the angle. Now for example, if I have two angles, the hypotenuse will always remain the same, but the opposite and adjacent will depend on the angle. So if I'm using angle alpha, it implies that this side will be the opposite and the remaining side AB will be the adjacent. However, if I'm using the angle alpha, it means that this side will be the opposite and the remaining side will be the adjacent. So the opposite and adjacent depend on the angle you are using inside the triangle, apart from the right angle. Always remember that. So like I told you, the order to label is first look for the longest side and call it the hypotenuse. Then from there look for the opposite, and after that the remaining side will be called the adjacent. Now let's go through the naming of these right angle triangles. Given an angle, what is the opposite, what is the hypotenuse, and what is the adjacent? That's what you're going to look at here. So always, like I said, always the longest side will be the hypotenuse. So that's the first thing to label. So I'll come and put hypotenuse here. Then because of the angle here, the opposite will be the side. So I'll come and put opposite. Then the remaining side is the adjacent. Same applies to this. Hypotenuse is the longest side, opposite is there, and the adjacent is there. Same applies to part C. Hypotenuse is the longest side, opposite is there, and adjacent is there. Same applies to this. Hypotenuse, longest side. So I think we've seen that the longest side is the side. Do you see this? It does not have the right angle. It is just the side opposite the right angle sign. The right angle. Then the opposite of the angle is there, and the adjacent is there. So basically that's how they label a right angle triangle. You label basing on the angle given. Always remember that. You label basing on the angle given. So now we shall go to trigonometric ratios. For a particular angle of a right angle triangle, the ratios opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent are fixed. These ratios have the traditional names sine, cosine, and tangent respectively, meaning this denotes sine, this denotes cosine, this denotes tangent. Okay, we abbreviate them as sine, cos, tan. So this is pronounced as sine, cos, tan, meaning that this is for this is for this, and this is for this. Now that means that sine an angle is opposite over hypotenuse, as you can see it here. Then cos an angle is adjacent over hypotenuse, as you can see it here. And lastly, tan of an angle is opposite over adjacent, as you can see it here. So these ratios can easily confuse, so a good way of remembering them is to use this term. They call it SOHCAHTOA, where SO is for sine, CA is for cos, and TOA is for tan. Now how is it used? How is it related to these ratios? We choose the first letter, so we say that is sine, and it will be opposite over hypotenuse. Then CA is cos, and it is adjacent over hypotenuse. Then TOA is for tan, and it is opposite over adjacent. So that's how this word SOHCAHTOA can be used to easily memorize the ratios, as we shall see. So we can use these ratios to find unknown sides and angles of right angle triangles, as we shall see. Let's start with the first part of finding unknown sides. So in a right angle triangle, if we are given another angle and a side, we can find the third angle using the interior angle sum of a triangle. Remember, for a right angle triangle, you already know that one angle is 90. Then when we are given a second angle, then the third angle can be got by using the interior angle sum of a triangle. But our emphasis for this part of finding sides is the second bullet, which is the other sides using trigonometry. So the other sides can be found using trigonometry. And the steps can be as follows. Step 1, redraw the figure and mark it hyp, op, and edge. This would mean hypotenuse, opposite, adjacent, relative to the given angle. So note this word, relative to the given angle, because to name these ones, you have to base on the given angle. Then step 2, choose the correct trigonometric ratio and use it to set up an equation. You have to remember SOHCAHTOA. Step 3, solve to find the unknown length. So if they don't specify the number of decimal places, you have to use 4 decimal places. So with that, we can go through this quick example. Find the unknown length of the following triangles. So the unknown is this, for this the unknown is this, for this the unknown is this, and for this the unknown is that. So we're going to use the steps which we have talked about. Let's first redraw the triangle given in part A plus the sides. Then from there, we said label them adjacent, opposite, hypotenuse. So of course the first one is this longest side as hypotenuse. Then the side opposite, when there is this angle, this will be the opposite, and the remaining part is adjacent. Then I'll come and say that from SOHCAHTOA, I want to get a relationship of opposite and hypotenuse, that is O and H. O and H is here, meaning we are going to use sine. So we shall come here and say that sine theta is equal to opposite over hypotenuse. Then you can substitute, the angle is 61. the opposite is x, and the hypotenuse is 9.6. Then we are going to cross multiply, take this on this side. Now from there we need to use a calculator. On the calculator we are going to press 9.6, then multiply sine. Now this symbol is my interest. It is there in your calculator. So for example, depending on the calculator you're using, if it is on, the sine symbol is here. So that's what I mean here. For this, the sine is here. So when you use that symbol, but you have to remember that here there should be a D. As you can see it here, I think you should analyze, there's a D there, meaning that it's in degrees. Why? Because this angle is in degrees. So when you follow this kind of pressing and press an equal sign, you will have to get this answer on your screen. But our interest is to get 4 decimal places. So I come and round off to 4 decimal places and come up with that. And that will be the answer they wanted. So I'll come and say that the unknown length is that in centimeters. That was part A. Then part B, we shall again redraw the triangle. Then label the sides hypotenuse. Then this will be the opposite and the adjacent. Now our interest is adjacent and opposite. That is O and A. And O and A is here, which is tan. So you come and say that tan theta is opposite over adjacent. Then you substitute the angle, then the opposite, the adjacent. Then you cross multiply. But I want to make x the subject, so I'll divide both sides by tan 41. Then I'll press my calculator in that order. When I press it, I'll come up with this value, but I need 4 decimal places, so I'll come and round off. And that will be the answer. Then part C, still the same procedure. Draw the triangle, label the hypotenuse, then the opposite, and lastly the adjacent. Now here we are interested in hypotenuse and adjacent. That is A and H. AH is here, which is cos. So I'll come and say that cos theta is equal to adjacent over hypotenuse. Then I'll come and substitute theta, adjacent, hypotenuse. Then I cross multiply. Then divide both sides by cos 64. Then use a calculator to get you. So you press in that order, and you come up with this on the screen. But we need 4 decimal places, and that's what they wanted. So basically, that's how they use the buttons of sine, cos, and tan. So yes, come and label. Then you label hypotenuse, then opposite and adjacent. Now our interest is opposite and hypotenuse. OH is here, which is sine. So sine theta is equal to opposite over hypotenuse. Then come and substitute theta, opposite, and hypotenuse. Then you cross multiply, divide both sides by sine 76. Then you can use a calculator. When you press those buttons, you'll come up with this on your screen, and our interest is 4 decimal places. So round off. Therefore, the unknown length is that. Now we shall go to finding angles. Remember, trig ratios can be used to get lengths, or unknown angles. For example, if I'm given this triangle with sides, those ones, so remember this is the opposite, this is hypotenuse. So I come and say hypotenuse, opposite. And the relationship between opposite and hypotenuse comes from SO, which is SOH. So sine will be opposite over hypotenuse, meaning that sine theta is opposite over hypotenuse, which is 3/5. Now, how can you get theta? You can get theta by taking this sine on this side. When you take it the other side, it becomes now arc sine, or you call it sine inverse. So there are two words. You can use the word sine inverse, inverse sine, or arc sine. They all mean the same. It means that you have taken the sine this side. Now, how is it got on the calculator? On the calculator, the inverse, I think you can see if you analyze these pictures, there are these words in yellow. It is sine, then like a power of -1. Then you have sine like a power of -1. So those are the ones we use to get angles. But how do you get them? That's what you're going to look at in the examples. So always remember that when sine goes this side, it becomes inverse sine. And in a similar way, we can get inverse cos and inverse tangent, as we shall see in the examples. So these are the examples we are going to look at. For each, they want the angle theta. So let's come and redraw the diagram. Then for here, this will be now the opposite. And the rest is adjacent. Now we have opposite adjacent, meaning that from SOHCAHTOA, OA is here, which is tan. Therefore, we shall come and say that tan theta is equal to opposite over adjacent. Then substitute for opposite and for adjacent. Now from there, I'm going to take tan this side. It becomes arctan. So in the calculator, to press arctan, you press it like that. So this is what I'm trying to get. Arctan 4/7, you press shift. When you press shift and tan, this symbol will come on your calculator. Okay, then they want this bracket, so that's why you press the button of bracket. Then they want this 4 divided by 7, so that's why they use this 4 divided by 7. Then you close the bracket and you press an equal sign. When you press an equal sign, this is the answer you'll get. But remember, the angles, we want 2 decimal places, so you're going to round off to 2 decimal places, and that will be the answer. When you go to part B, it is still the same. Identify the hypotenuse, then the opposite, and lastly adjacent. So now we have hypotenuse and adjacent. So AH from SOHCAHTOA is here, meaning we are going to use cos. So cos adjacent over hypotenuse. Adjacent is this, hypotenuse is this. And to get, when cos goes this side, it becomes arc cos this. Therefore, to press in the calculator, remember we said inverse cos, you first press shift. So press shift, cos, then open brackets, this, which is here, close the bracket, and press an equal sign. When you do that, you'll come up with this as the angle. Then part C, still redraw. So I'm just repeating for you to understand the concept. So come and label hypotenuse, opposite, adjacent. Then go to your SOHCAHTOA. We're interested in OH. OH is sine. So you shall come and say sine theta is equal to opposite over hypotenuse. Therefore, come and substitute for your opposite and for your hypotenuse. Mean that so for sine to go this side, it becomes arc sine or inverse sine, whatever. And to press the calculator, to press this inverse sine, first press shift. So I'll come and first press shift, then sine, open brackets, 7.2 divided by 12.4, close bracket, equal to, as you can see it here. The answer will be this, but we're interested in 2 decimal places. Then part D, still draw the right angle triangle, label the sides, hypotenuse, opposite, adjacent. We are interested in AH. So AH is here, which is cos. So I'll come and say that cos theta is adjacent over hypotenuse. So substitute for your adjacent and the hypotenuse. Then when you take cos this side, it becomes inverse cos or arc cos. Then to press arc cos on the calculator, I first press shift. Then cos, open brackets, 9.45 divided by 12.06, close bracket, equals sign. You will come up with this answer. But you need 2 decimal places. And that's the answer they want. That was now getting angles. Now shall go to another term called elevation and depression. Now that you have got understood how to get angles, it means you can go through this. So the angle between the horizontal and your line of sight is called the angle of elevation if you are looking upward, or the angle of depression if you are looking downwards. So elevation, for example, if this is my eye, I will draw a horizontal line at my eye. So if I look up to focus to locate this object, the angle I make is called angle of elevation. But if I look down to locate this object, the angle I make is called angle of depression. So depression downward, elevation upward. That's what you should remember. But when answering these questions, you should remember you should remember what you have covered earlier. One is properties of isosceles triangles and right angle triangles. When I talk about right angle triangles, I mean Pythagoras theory and SOHCAHTOA. Then properties of circles and tangents. You already saw that video. Then angle of elevation and depression, which you have looked at now. So with that, you can go through these questions. One says, a model helicopter takes off from the horizontal ground with a constant vertical speed of 5 meters per second. After 10 seconds, the angle of elevation from Sam to the helicopter is 62 degrees. So it is angle of elevation. Sam is 1.8 meters tall. How far is Sam's head from the helicopter at this time? So we shall need a sketch. Now and this sketch we need the height, so we said they've given us the speed and the time, meaning you can get the distance. Remember, distance is speed times time. I think you learned that in the primary. So speed, and actually this is where the assignment will come from. Speed times time to give you 50 meters. Then you can come now and make a sketch. Now here you don't need the actual diagram of a person and actual diagram of a helicopter. What you need, because we need the logic, the mathematics behind it. So that's why you see me just drawing a rectangle and call it a person, Sam. Then I also come and draw a rectangle and call it a helicopter. As simple as that. So you don't need to overmake a sketch of a helicopter and a sketch of a person. Now the helicopter is 50 meters high from the ground. But the good thing, Sam, is we know the height of Sam. And remember, for elevation, we draw it at the eye. So this is where the eye is. That's why you come and draw this horizontal line to help us measure the angle of elevation. Now on the 50, if I subtract off 1.8, I'll come up with 48.2. Meaning that now the angle of elevation is there from A to B. And the distance they want is this x. We don't know it, but the good thing, we know the angle inside the right angle triangle and also the side. And by now I believe you can easily realize that this is the opposite and this is the hypotenuse. Therefore, opposite and hypotenuse we use sine from SOHCAHTOA. Therefore, we shall come and say sine 62 is equal to opposite over hypotenuse. Cross multiply and make x the subject. So when I make x the subject, means what I've done, I think this is the same steps we have been doing before, but in the previous step I would say first cross multiply and then divide both sides by sine x. But now I believe you can now understand this. What I've done, take this one this side. It was denominator, it becomes numerator. Take this one this side. It was numerator, it becomes denominator. That's what I've done on this step. It's also a rule which was learnt under algebraic expressions, solving equations. Then I now need a calculator. When I use the calculator, the whole of this, I believe by now you know how to press it in the calculator. You'll come up with this. And that will be the distance of Sam's head from the helicopter. So now I shall also go through question 2. Question 1 was about elevation. Question 2 is about depression. So it says, from a vertical cliff 80 meters above sea level, a fishing boat is observed at an angle of depression of 6 degrees. How far out to sea is the boat? Now this word is a little funny, but you shall see what it means. So we need to make a sketch. A cliff is a raised ground. So this is a cliff and it is 80 meters high. So from here to here, it is 80 meters high, and this is the sea. Like I told you, here we use rectangles because we didn't need that too much fine art. So this boat, we just draw a rectangle and call it a boat. It is still okay in math. Now, how far out to the sea? They mean this distance along the sea. Otherwise, it would have been the distance from here up to here, if it was this from the top of the sea. So how do we get this distance? We are going to join, and we know that the depression is measured from the horizontal, which is 6 degrees, and from the angle properties we learned in week 1, this angle is equal to this angle because they are alternating. Now we have a right angle triangle, and by now with this angle you can easily realize that this is opposite and this is adjacent. Now opposite and adjacent we use tan. So tan 6 is equal to 80 over x. Then I make x the subject. Then I use a calculator to come up with that. Then I conclude that the boat is this meters out to the sea. And that's what they wanted. So in this video, I'm going to leave you with 2 parts. One will be an exercise strictly on trigonometry, because trigonometry is more sensitive and you need to understand it. Then we shall also have a math contest assignment. That math contest assignment will contain questions on motion. I think you remember I gave you a hint that distance is speed times time. Now the question is, can you use that formula to come up with solutions when the question is treated in a math contest way? That's what I'm interested in. So both are needed. We need the exercise and also the assignment. So that has been the exercise. Now we shall go to the assignment. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on trigonometry part 2. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the video has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so you can all benefit as a family. Hello viewers, Ugadoruna taking you through the story of O-level math contest practice. And this video we're going to go through the topic of trigonometry part 2. So this video is suitable for students in both senior 1 and senior 2 with passion of one day participating in the national math contest and thereafter math olympiad. So we are now in day 2, and that will be trigonometry part 2, where I'll leave you with an assignment 2. So in trigonometry part 2, we need to look at area of a triangle using sine rule. Now previously, under the video of the area and perimeter in geometry, we looked at area of a triangle, but in that case, we are supposed to have a base and a height. So the question is, what if you don't have the base? What if you don't have the height? What do you do? So that's what you're going to look at in this video. We use the method, the knowledge of sine. So the area of a triangle is half the product of two sides and the sine of the included angle. Included angle means the angle between two known sides. So this side is known as 5, this side is known as 6, and this side angle is known as 30. It implies that you can get the area of that triangle. So let's try to see this shape. So in that case, let's put the angles of the 3 and the sides. Now I want you to notice something about the sides. This angle corresponds to small a, capital B corresponds to small b, capital C with small c. So the small letters are the lengths of the sides and the capital letters are the angles at those vertices. Meaning that if C is known, for you to get the area, you need to know these sides which enclose the angle. And therefore the formula will remain the same. Half the product of the two sides and the sine of the included angle. So half the product of the two sides, product of two sides is that, then half of their product, that's why you put half, and the sine of the angle of the included angle, which is sine angle C. That is if we know angle C. What if we know angle B? If we know angle B, it means that the sides to use will be this and this. Therefore, the area will be a half of the product of the two sides times sine of the included angle. Okay, what if you know angle A? It means the sides you will use will be B and C. Therefore, the area will be half the product of the two sides times sine of the included angle. So any of the three formulas is okay. It is up to you to realize that you have an angle and two sides enclosing that angle. Then you can easily use this formula. So let's try to do some questions for you to master the formula. What if you are told to find the area of these triangles A, B, and C? The good thing is that we have an angle and the sides enclosing the angle. Therefore, for part A to be half the product of this and this. As you can see it here, the product of those two sides are this, then half of them times sine of the included angle. Then from there, use the calculator and you realize that you come up with that. Same applies to part B. We have this side and this side, so half of the product of those two sides that, half of the product times the included angle. You'll end up with this. For part C, still do the same. Product of the two sides is 28 times 25, but half of it times the included angle. So as simple as that. So in this method, you don't need to calculate the height. What you need to know is to get the angle enclosed by two known sides, and you'll be able to get the area of that triangle. Okay, so that was one concept. Remember, we are now in trigonometry part 2. In part 1, we are interested in right angle triangles. But now, what if the triangle is not a right angle? Is there a way you can work out what they want? So that's what we were interested in this video. So next we have what we call sine rule. So the sine rule is a set of equations which connects the length of the sides of any triangle to the sines of the opposite angles. So by now we know what an opposite angle is. We are going to see how to get it. So triangle does not have to be right angled. In part 1, trigonometry part 1, the triangle was right angled, but now even if it's not a right angle triangle, you can solve it. So consider a triangle ABC with sides A, B, and C and opposite angles capital A, capital B, and capital C respectively. So that is a triangle ABC. It has angles capital A, capital B, capital C, and sides. So the sides are opposite. So for this angle, the opposite side is that. For this, opposite side is that. For this, opposite side is that. So we must be keen when labeling. And when you label correctly, then you can come and state our sine rule. Sine rule can be stated in two ways, but they all give the same answer. For example, I can say, I want you to note something. The angle with its opposite side, A over sine A. Angle with its opposite side, B over sine B. Angle with its opposite side, C over sine C. Now this is what we call sine rule. There are two equal signs, meaning that it is you to choose any of the two. You can say, let me first equate these two. And so that reason that they talked about this word set of equations, because you can get more than one equation. Actually, you get three because you can choose to pair A and B, or you can pair B and C, or you can pair A and C like that. Now this other part, actually this one is used when the unknown is a side. For example, when they want you to find one of the sides, it is better to put the unknown in the numerator. Then if they want you to get an unknown angle, it is better to put the unknown angle in the numerator. That's why we just get the reciprocal of the first one. So this is the reciprocal of this. As simple as that, but the rest is the same. So basically that's what we call sine rule, but you must be keen to use angle and its opposite side. Angle and its opposite side. Angle and its opposite side. You don't interchange. So when do we use sine rule? We use sine rule when we are given either two sides and an angle not included between these sides, or when we are given two angles and a side. So that you can go through these quick parts. Remember, there are two options. We can tell you to get the side length of the side, or to find an angle at one vertex. So we shall look at both options, but let us begin with the first option where they want you to get the length of a side. So in this case, they have given us two angles and one side, meaning you are going to use sine rule. Same applies to this. We should realize there are two angles and one side, so you can use sine rule. Even here, two angles and one side, so you can use sine rule. So let's start with part A. For part A, we are going to first code the formula, then come and substitute. So this one is not mandatory that you should write it. What we want is you to state this one correctly. How do you state it correctly? You'll come at x and say x must correspond to this angle. So when I see x here, in the denominator I must see an angle of 32. Okay, then 15 must correspond to this angle. So when I come and see 15 here, down in the denominator I should see an angle of 46. When you do that, you have stated sine rule correctly. Now next is to simplify and make x the subject. Of course, the first thing to do is to, if I want to make x the subject, I'll have to take this one, this side, by multiplying both sides by sine 32, which gives you that. Then I'll need to use a calculator. I believe by now you know how to press sine 46 and sine 32. So when I press the whole of this in the calculator, I'll come up with the value of x as that. That is part A. Part B, we are going to still follow the same procedure. This one you can quote it or not. What we're interested in is that if I see x here, then down I must see an angle which is opposite. If I see 9 here, then down I must see an angle which is opposite. If you can master that, then you have quoted sine rule correctly. And the next thing is to make x the subject. So I'll bring this on this side to come up with this step, then use a calculator to come up with that as the value of x. Lastly, still part C, still do the same sine rule. We're not interested in this, but we're interested in the substitution. So when I see x, I should see 55. When I see 6.3, I should see 84, which is this. Then next is make x the subject, and that's what they wanted. So basically that's how sine rule is used to find lengths of sides. But I also go through example 2. Now example 2, in example 1 they drew for you the triangles and they labeled for you the sides and the angles. What if they don't do that for you? It is up to you to realize that small letter corresponds with the capital letter. Small letter corresponds with the capital letter. So I will come, let's say part A. I'll come and first draw my right angle and label it ABC. In any order you want, you can choose to put A here, B here, and C here. Because what we are interested in is that an angle and this should be opposite each other. That is the only thing we are interested in. So if I come and put A here, so this A, if I put it here, I'm putting it here because of this. Do you see that? Realize this? This is capital A, this is A. Therefore, where there is capital A, I'll come and put an angle of 65. Then where there is capital B, I'll come and put an angle of 35. Where there is, now small b should be opposite capital B. So that's why I'm going to put 18. When you do that, you have mastered what we call labeling a triangle. So after labeling, now we can go ahead and use sign rule. Sign rule, what we're interested in is the order. So if I see small a here, down I must see 65. If I see 18, down I must see 35. That means you have mastered sign rule. The next is to make A the subject. Use a calculator and get the value they want. Then part B still do the same. Draw a triangle, label it. So that means that small b will be here, opposite capital B. Then capital A will be put here. Capital C will be put here. And small c will be put here. There you have labeled what is given, and they want you to calculate, they want you to get the value of b. Now there's something funny here, because this capital B is not, we don't have capital B here, but they want you to get small b. So what do? You'll come and put an unknown here and call it capital B. Now what is capital B? The good thing, we have these two angles, and we already know that angles of a triangle add up to 180. Therefore I can come and first use that concept from geometry and get the value of capital B. After getting capital B, I can now use sign rule. Sign rule will state that b over small b over this, which is 81, is equal to 24 over this, which is 27. Then make b the subject, and that will be your answer. Then for part C, still come and draw the triangle and you label it. Then small c will be put here. Capital B will be put there. Capital C will be put here. Small a will be put here. They have labeled what is given. Now they want us to get the value of C. Now here still there's something fun. Do you realize it? This is okay, but this side does not have an angle here. So we're going to still use angles of a triangle to get the value of capital A. So angles of a triangle add up to 180 degrees and make A the subject, and that will be that. Then we can now use this with this and this with this to get the value of C. So substitute in sign rule, make C the subject, and use a calculator. That was about finding sides. What about finding angles? So example 1, they said solve for x. Here they want you to get the value of x, and also here these are angles. So you realize that this corresponds to this and this corresponds to that. So you can use sign rule. Therefore shall come and say that sine x over 14.8 is equal to sine 38 over 17.5. Then make sine x the subject. Use the calculator to get the whole of this value. But remember this, they want the value of x, not sine x. So I have to take the sine this side by introducing inverse sine. I think by now you know it, based on what you covered in trigonometry part 1. So inverse of sine this will give you an angle. Now the angle is to 2 decimal places. So that was part A. Now part B, they want the value of x. But there's something funny here. Do you realize it? This x has no, this side is not known. Also this angle is not known for this. So what we do? The easiest is to first get this out, put an unknown angle there. Then you shall remember that if I use sine rule, this and that, and this with this, I'll come up with this statement. Then I can be able to get the value of y. So cross multiply to make sine y the subject. Use the calculator to simplify this. Then take this sine this side to become inverse sine. Then use a calculator to get the angle. After getting the angle of y, it means I can get the angle of x because of angles of a triangle. So angles of a triangle add up to 180 degrees. So come and substitute, simplify, and make x the subject. Now I've got an angle, meaning, and that's what they wanted, because they wanted us to solve for x. That was example 1. Example 2 still, what if they don't draw for you the triangle? We are going to follow the same concept used previously when finding sides. So get the triangle, label it in any way you want, but remember that small a corresponds to capital A, capital B corresponds to small b, like that. So they want angle A, so I'll come and put angle A. If small a is here, small b is here, and angle ABC is at B. So now that we have that, we can now use this with this and this with this to get the sine rule where you can solve. So take this one this side, come up with this, use a calculator, then inverse of sine gives you the value of A. Using calculator you get that. Then for part B still, we are going to draw our triangle and label it. Then angle B is put at vertex B, small b is put opposite B, capital B, small c is put opposite capital C, and angle SCB is put at C. Then this corresponds to this and this corresponds to that, meaning you can now state sine rule. Then make sine B the subject. Use a calculator to come up with that. Then take this sine this side to get inverse sine, and use a calculator to get the angle of B. So this will be B. Then for C, still the same. Draw a triangle. Substitute angle C, put at C. Side A, put at that point. Side C, put at this point. BSC, put at A. Then rather than we have this and that, so you can quote sine rule and make sine C the subject. Use a calculator, simplify. Take sine this side to get inverse sine, and lastly the angle will be that, and that's what they wanted. So now we shall go to example 3. It says Mount X is 9 kilometers from Mount Y on a bearing of 146 degrees. So let's first illustrate that. Shall come and draw a compass direction where Y is. Then shall locate X on a bearing of 146. Remember, bearing you measure from starting from the north up here. That's where the 146 is. So X is 9 kilometers apart, 9 kilometers from Y. Then they said Mount Z is 14 kilometers away from Mount X and on a bearing of 0.72 degrees from Mount Y. So let's start with this statement of bearing. Bearing of 0.72 from Y. So we shall come at Y and measure off 0.72. Now here we don't use protractor. We are going to use calculation, so you only sketch. So this 72 is not exactly 72, it is just an estimate, because what you're going to do is calculation. Remember in class, you used protractors and you also used graph papers to draw these bearings. But now we don't use graph papers and we don't use protractors. So that means that they told us the distance of Z from X is 14 kilometers. So we shall come and join from X to Z, and that will be 14 kilometers. So this angle here will be, remember from here theta is 146 and from here theta is 72, so the balance will be 146 minus 72 to give you 74 degrees. For this one we don't know it, so we shall put an unknown. Even this one we don't know it, we shall put an unknown. Then this x, now why are we putting this x? It is because they want the bearing of x from z. So from z you come and get this angle. So for you to get that angle, we already know that from here theta is 180, but from here theta we don't know it, that's why we put an unknown as x. So when you get x, you can just add 180 to get the required bearing. Then from there, this if this is 146, then the remaining angle will be 34, and this alternating with this 34. So it will help us, because if we get the value of alpha, we shall remember that alpha is equal to 32 plus x. Now, how can we get alpha? One, you cannot use sine rule immediately to get alpha, because this angle here corresponds to this side, but this side is unknown. So what you're going to do, you're going to use this angle with you're going to use this angle with this side, and also use this angle with this side to generate sine rule. So let's do that. Then cross multiply, simplify to get sine theta, then get the inverse sine by taking sine on the other side. Using a calculator, you come up with the value of theta. So I know this angle as 74 and this one is theta as 38.17, meaning when I use angles of a triangle, I can get the value of alpha. So substitute for theta, simplify, collect like terms, and that will be alpha. So now that I know alpha, I remember that alpha is equal to the sum of these two angles. So substitute for alpha and make x the subject. Now that I know x, I can easily now quote the bearing of x from z. Therefore, I'll come and say the bearing of x from z is 180 plus x, then substitute for x, and that will be the bearing they wanted. That was sine rule. Now we shall go to cosine rule. So we shall consider a triangle ABC with sides this and opposite angles that, as shown below. So I'm going to draw the same triangle we used under sine rule and label it the same way. Those are angles, then we put the sides. So cosine rule for this triangle can be stated in three ways as follows, depending on the angle you want to be included, because cosine rule, all the three sides should be known and at least one angle. So if this angle is known, it means that if capital A is known, I'll start with side A. That's the trick behind it. You see, I started with A squared, then equal to B squared. The remaining two sides are B and C. So that's what will be here. B squared plus C squared minus 2BC cos A. You notice something? What is, if here is small a, here there will be capital A. Then in between are the remaining sides. Same applies to B. If here there is small b, here there will be capital B, and in between are the remaining sides. If here there is small c, here there will be capital C, and in between are the remaining sides. That's what you should note when it comes to cosine rule. So when do we use cosine rule? We use cosine rule when you are given two sides and the included angle between them. For example, if I'm given A as the angle and these two sides, then you can use cosine rule. Also, you can use cosine rule when you're given three sides of a triangle. So that we can go through these questions. We are given these two sides and the included angle, and they want us to get this side. There I can use cosine rule. So I come and say that this side, because this is the known angle, it will correspond to capital A, meaning that small a will be this x, and the remaining sides B and C can take up any. So one will be B and the other will be C. So let's come and substitute. So in this case, 21 is B, 15 is C. Even if you interchange, it is okay. What we are interested in is this. The known angle and the opposite side must be at the extreme end. Known opposite side is this, and this corresponding known angle is that. Then we are going to use a calculator. This squared is that, this squared is that. Then the whole of this, when you press the calculator, you realize that you get a negative. The negative with the negative gives you a positive. Therefore, you come up with this when you add. Put square root to get the value of x as that. It is 4 decimal places because this x is a length. If it was an angle, it would be 2 decimal places. Then for part B, it is the angle which they want us to get, but they are giving us all the 3 sides. So still the opposite side of that angle should be at the extreme end. So from that formula, this A is now A, capital A is now x, and small a is now 12. Then B and C can be any of these 2 remaining sides. So I'll come and substitute, simplify this, and the whole of this. Collect like terms. This plus this is 130. So from here, I'm going to collect like terms. This will go this side to come up with 14, and here it will be a negative. I want to make cos x the subject, so I'll divide both sides by negative 126. I can reduce this fraction to give me negative 1/9. Then take this cos this side to get inverse cos. And using a calculator, you'll come up with that as the answer. So we're using 2 decimal places because x was an angle. Then example 2, an aircraft flies 74 kilometers on a bearing of 038 degrees and then 63 kilometers on a bearing of 160 degrees. Find the distance of the aircraft from its starting point. So we come and first locate the starting point, and then we measure off 038, a bearing of 038. Remember, we don't use a protractor, we just sketch. 38 is here, the distance moved is that. This will be alternating to this. Then from there, the next was 160 degrees, and the distance was 63. And the balance here will be 20. Then you can join, because it asks for the distance from the starting point to the final point. Let it be x. Now the whole of this angle will now be 58. So this, I have that. So that means that these two will be at the extreme end. When you're starting our cosine rule, we shall start with x. As in 58 will be capital A and x will be small a. Then these two, one will take up one and the other will take the rest. So simplify, this gives that, this gives that, this gives that. Simplify further, put square root on both sides, get the value of x, and that will be the distance they wanted. Now I'll leave you with an assignment for you to try out. that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on factorials. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so you can all benefit as a family.